There we go. Now we have sound. Okay, that was yeah, it was all my fault. Okay, so first off, DDT 2005. Thank you for the. I'm trying to scroll this. It's really hard. Tier 1 sub, and for 7 months. Wow. And Generic Sweetener, thank you for the Tier 1 sub, and for. Oh man, it did it. Wait, why did it not work? Oh my gosh, I'm an idiot. Hold on, one moment. I will manually run that. Give me one moment. I can manually run that, so I will do that. I did a dumb. Where is it? There we go. It helps to encode strings as strings. Sometimes I added a last minute change to log all of the deck talk things that are said. So there we go. Now it will work. And I will run your last message there. I have it set up so I could do that. Just to make sure everything's working. That, oh my gosh, one moment. It would help if I actually copied the text. Oh, where did...
Starhawk says CHER-152 lol. End of line.
That worked. It works. Oh, that's awesome. Okay, but one moment. I've got to do this one.
Dodgerson says CHER-100 chugga chugga toot toot. End of line. CHEER 100 bits per sound.
There's dog faces. Okay, it is working. Oh, yes. Oh, that's awesome. Okay, so let me...
Satorskum says CHEER 100. Yay, the deck talk is up and running. End of line.
How about that? Louder? Okay. Oh, man. All right. So, okay, I gotta catch up here. First off, Chartreuse, hello, since it's your first time chatting. I'm hoping the clone does go easily. Dogface, thank you for the 100 bits. Sorry it didn't work out correctly there at first. Starhawk, thank you for the 100 bits. NeoDragon90, thank you for the tier 1 sub and for 4 months. Dogface, thank you for the 100 bits again now that I got it working. Tater's Game, thank you for the 100 bits. And yeah, there we go. The Industrious Ant, the ads are running. They shouldn't be. They should be.
Commander Keith says CHEER 250 PCB cloning train. End of line.
How was that volume-wise? Was that good or was that too loud? Good? Excellent. Awesome. All right, I'm going to turn down the speakers a little bit so I don't hear the buzzing as much. Is there like a constant buzz sound going on now with it being that loud?
Douglas McDodgerson says CHEER 100. Are you able to show the P4? I am trying to explain it to someone right now. End of line.
The sign? Do you mean the sign? Because I can. If you want me to do that, I can. All right, I will be right back. I put it somewhere safe. Yep, here it is. This is something Dogface gave me recently. This is a fluorescently illuminated Pentium 4 badge metal sign. It is actual metal. It's really incredible. So, yeah, that's something that I'll be mentioning when I go over a mail video at some point. So, yeah, that is awesome. So, there you go. Okay, so the people who are having ads, I tried to...
Starhawk says CHEER 100. The deck talk may not be from McDonald's, but I'm loading it anyways. End of line.
So, let's see. I'm gonna need a big case for that badge. Yeah, no problem, Dogface. What was I going on about here? There is a little buzz, but low enough to hide in the background noise. All right, that's good. That's good. Chartreuse, thank you for the Prime sub. Let's see. Can you guys pause the stream for a few hours so I can go watch yesterday's first? Sorry, G-Pin. It's not going to be all about the deck talk. It's just that we have the deck talk running, and I think people are going to like it. On that note, okay, I got a couple of things to go over. One, the problem was that when I plugged the deck talk into power and had it all connected like normal to the stream computer, there was this horrendous ground line hum. It was completely unacceptable. And I don't know why it was happening. I think it's something with the serial cable and the USB port grounding it together. Just instant, just garbage output. So it's actually running wirelessly right now over audio. I don't think I can easily show this here, but this is one of my wireless mic packs that I use for my lavalier mic. It's a stereo set, so I have the other one connected to the deck talk up there now.
Douglas McDodgerson says CHEER 100 level 3, let's go. End of line.
Okay, I really, really like having the deck talk on here. This is kind of awesome. Tater's Games, thank you for the 5 gifted subs. Wow. Thank you so much. Let's see. Yeah, so the thing is that I do need some grand loop isolator type things. Yeah. So I got to figure that out, and then I think it'll work. But for now, the wireless solved the grounding issue because it's just not connected to the mixer at all, like physically. So that kind of solved it. DJ Chol, kind of. Stephen Hawking used a deck talk, but I don't know exactly what the voice setup was for him. It might just be Perfect Paul, which is what this is, but I'm not 100% sure. I haven't actually looked into it yet. So, about the deck talk being connected, if you scroll down below the stream, at least on the web thing, I don't know how you get to it on mobile, you can see I put information about using the deck talk and also the Call Me and Byte Break down below. I finally added one panel that wasn't just the Twitter feed down below there.
Starhawk says CHEER 101 last push over the edge. This is all the bits I got, lol. End of line.
Thank you for the 100 bits. See, I've actually made an isolation for audio out of transformer from a modem. Oh, interesting. That, I might have a couple of those. Although I figure all the ones with transformers are probably the ones that I want to keep, so I probably won't do that. One of the things I did is, Diego the Artist, it only works with bits. That's the thing. I figure that putting it behind the monetary gate will rate limit it enough to not be annoying. So yeah. So end of line. All right. That's going to go into some other things. So if you look down in the panel about it, you'll see that I put a command alias %p. The thing is that there is a minimum. It's 100 bits. Dogface. There is a minimum. That way there's some kind of commitment that has to be made for it. Because you only have, like, 500 characters for a chat message, I figure if people want to actually try and do complicated things with the speech to text, because all options are available with this. You can do anything through it right now. I figure that, like, the phoneme enable is a super long command, so I put a shorthand command in there. So if someone tries that, to do like a singing thing, put %p in front of it instead of the full phoneme start, and that should do the same thing. I have not been able to test it. I actually am not allowed to cheer on my own channel for some reason. I'm guessing it's in case you manage to get a Twitch gift card for less than the dollar value, so you can't just make money off of it that way. So it's really, really hard for me to test it. I have to either make another account and then put money into it, which I'm pretty sure.
Douglas McDodgerson says CHEER 100 fly me to the moon.
Okay, I'm guessing it worked there. So Dogface, you have to. There's a. I don't think you were here for it. So if you, there's a whole command structure. You have to do different pitches and durations and commands on each phonetic sound to get the singing to work. So yeah, you can't test the script in another fashion. I can, I have a forcing script that I can do. So I can do something.
Attack says CHEER 100 end of line. End of line.
So I can force this.
We're whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
So I can do that, but it doesn't test it through the Twitch interface, and I just wanted to make sure. Dogface, give me a moment, and I can actually do that.
End of line, says CHEER 100 end of line. End of line.
Thank you for the 100 bits, end of line. And also Beats Attack and Dogface again. Let me figure out what the singing command was here. So Twitch. There is a happy birthday example. Oh no, where was the still alive one? Actually probably in my command history, so. Was that one of the last ones I did, or was it really far up there? Yeah, the line is now ended. Yeah, so the end of line thing. Okay, so there's the command alias at the beginning, and that is to enable phoneme. To get it to actually work and make sure that it works consistently, I had to make sure that it ends, the line ends. So I had to have a period and then some text and then another period, because the way that it works is it will not start pronouncing stuff until it actually has a full sentence to speak. So I had to make sure there was excuse me, always a full sentence in there. So I had to add something to it. So end of line. Now, if anybody, I'm pretty happy with how it sounds, first of all, but if anybody wants to create a phonetic thing that better matches the master control program, I will replace it. But for now, I'm pretty happy with that. So, yeah. But for the record, I have the end of line. Commander Keen, thank you for the 5 gifted subs. Wow, really appreciate that. Never change end of line. Oh, I won't make it worse. The only it might be better or possible to make it. What is it? It might be possible to make it. What's match the line from Tron more. See, Portal song. Oh yeah, that'll work. Thank you, Helen Croft. Yeah, I think you got it there. I'm distracted looking at a bunch of stuff here.
Pro engineer says CHER 100. Command error in command. I can't let you do that, Shelby.
What is 90 supposed to do? That didn't work. Also, thank you for the 100 bits. Anyway, I was gonna link or paste in. Why can't I select text? Anyway, here is. If it'll let me get it.
Douglas McDodgerson says CHER 100. Da 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 da. End of line.
Perfect. Okay, it works. It works. Oh, that's nice.
Richard RMS Stallman says deposit CHER 100 dot for the next 3 minutes dot. End of line.
So yeah, the singing works. That's so cool. So I was gonna paste in the happy birthday text, but that works. That demonstrates it. So the happy birthday demo is in the manual that I have linked. Yeah. So there we go. All of the features work. Oh, that's cool. That is really awesome to have that.
Douglas McDodgerson says CHER 100. This was a triumph by making an OD food success. It's hard to overstate my satisfaction. The pitch is science. With a what? End of line.
Yeah, there's a limit for the chat, so that's it. Oh, that's
David Fenton says CHER 100.
I wonder if this works. I'm not sure what it will do, but it should do something.
End of line.
This is a lot of fun. I like the deck talk so much. This is so cool. So yeah. Anyway, what I was gonna say is you may have noticed that you're able to do the commands. It will attempt to reset as many parameters as possible after each line. So after end of line in my script, I actually have a bunch of other commands that run every single time that tries to reset it back to normal. There apparently isn't one global reset command, which is probably good because it might say the deck talk powered on, whatever nonsense. So yeah, I try to reset each parameter individually. So yeah. See, we need end of line emote now. I wouldn't be against that. Might want to look into that. Also,
Douglas McDodgerson says CHER 100 SL 15,000 and 28 I 15,000 and 28 grade 30,000 and 37.
Oh, you didn't do the percent P first.
30,000 and 33 MMS 50 WEF 15,000 and 33 MNA 15,000 and 33 MM 50 LA 15,000 and 28 N 15,000 and 28 IH 15,000 and 28 NBEF 15,000 and 27 at 30,000 and 25 DD50 Go 15,000 and 26 Esto 15,000 and 26 Jeff 15,000 and 37 Tito 30,000 and 35 Titwa 15,000 and 33 TTS 50 15,000 and 35 MA 30,000 and 37 Psi 30,000 and 33 DD50 I 15,000.
I'm gonna manually run it after it stops.
I 30,000 and 33 MM10 15,000 and 33 Liv 15,000 and 35 NPF 15,000 and 28 Co 30,000 and 26 Lear 30,000 and 25.
I can't believe it can be made this long through the chat.
15,000 and 28 Way 30,000 and 37 Kit 15,000 and 37 NNTH 20 of 15,000 and 37 more 20,000 and 33 N in 20,000 and 33 I 20,000 and 33.
So the problem with the Cheer 100 thing is that that can be at any point in the text. So it's really hard for me to filter it out. All right, I'm doing it with the %P now.
%PSO
Oh no! No! I messed it up!
28 grade 30,000 and 37.
How did that? That did not have the %P functionality built in. I'm an idiot. Oh no.
15,000 and 33.
Oh, so stupid.
33 MM50 lay 15,000 and 28 N 15,000.
One moment.
28 IH 15,000 and 28 N BET 15,000 and 27 at 30,000 and 25 DD 50 Go 15,000 and 26 S 15,000 and 26 Jeff 15,000 and 36.
Bleh. And boop. Reset. Give it a moment.
Dead Talk Express is running.
There we go.
External power on. So I cry sometimes when I'm lying in bed, just to get to 20 minutes and I'm feeling peculiar. So I wake in the morning and I command error in phoneme H and of line.
Oh, that's
JJDB 210SIZHEER 100. Hey, I just met you. And this is crazy, but here's my number. So call me, maybe. And of line.
that one worked really well. The phone system is not connected to the deck talk. It's not really practical to do that because all of my audio hardware runs through a physical mixer. So the only way I could record the deck talk to play it back through the phone would also include my voice. And I'm usually talking in the streams. So it would be where the deck talk starts talking while I'm talking, and then I'd get a phone call with both me and the deck talk talking at once. See, maybe it messed up because another message came in. Ooh, is that possible? That might be it. Macrotronics, it's actually connected to stream now. That's how it's being sung. It's if you do a cheer of technically over 99 bits, then it will actually work. So, yeah. Oh, yeah, I forgot to mention. Time H 313. Hello, since it's first time chatting. And there were so many. Thank you, everyone who's cheered 100 bits so far to make it sing. This has been a lot of fun. So, yeah. But yeah, deck talk working. I will probably optimize this as much as I can.
Dodgerson says CHEER 100. Da, 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 da. End of line.
Yeah. So the %P will make it sing. That is a shorthand for the full phoneme ARPA-bet enable whatever line. It's so long, that command, that it'll really eat into your ability to make it sing. So yeah, that's what the %P for. It's just a shorthand. So, but yeah, all right. Should we actually get into the topic at hand today? Had 25 minutes now of just playing around with the deck talk. And Janko Tech, you have missed us playing around with the deck talk because it's actually working in stream now. So yeah, and the latest new Tech Dangerous motto. But yeah, so I think we should probably continue on here. So okay, how awesome would it be if that could sit behind .sing. I mean, it could be .sing, so if I think I needed this, well, that's cool. So the .sing, I assume it. Oh man. Yeah. So that still works. Also, that's now restricted to just the Call Me Redemption. So Byte Breaks will not actually activate that anymore. Hello, THFD THG, since it's first time chatting. So now you have two ways of being annoyed. Yes, so the idea is that the deck talk is more fun, that, you know, everyone can hear it at any time. The phone is for getting my attention. That's kind of what it is. That's why the phone is just channel points, and then this is with bits, just so that that would allow you to have fun whenever you want. It's just restricted in other ways. So, all right. Let's see. Only we can pause the call me, we can't pause the bits. No, I would have to stop the script, which would stop both. That's how that would work. So for the record, if you missed the phone stream where I set up the phone so that I can be called, the way this is running is that I have a Python program that hooks into the Twitch API in the background, and it receives event information, and I have it hooked into channel point redemptions and now cheers. And when a channel point redemption happens, it'll look now to make sure that it is the call me redemption, and then it will actually send a command that rings the phone. And if it is a channel point redemption, it checks how many bits it was. If it's over 99, then it will send any message that was attached to the cheer out to the deck talk over serial. So that's how that's working. See. 1K bits on deck talk. It's pretty sweet, though. See, it feels like your ultimate goal is to allow someone to hack into your Whopper system live on stream for maximum interactivity. Kind of. You know, JJ's got the hat in the backgrounds of his stream. It would be kind of interesting if I had like a pixel grid thing here that someone could modify somehow. I wonder how that could work. Oh my gosh, I had an amazing idea. There could be like, it is open source, yes. It would be interesting if I could have some kind of game going on in the background on like a display or something where it could be turn-based, and then you could run commands or something to play the game in the background. I don't know. I don't know if we need that much interactivity. But yeah, that would be interesting. Anyway, let's actually get into today's subject. So this is my Philips CM-100 CD drive. That's the first CD drive ever. Period. So this is a 1985 CD-ROM drive. It predates ISO 9660. This uses the High Sierra file system. And I have no idea if it works, because it also doesn't use IDE, SCSI, or anything like that. It uses LMSI as the interface. Now, I've tried to buy an LMSI card. Actually, I forgot I was going to bring it over here. One moment. I have it just plugged into my test bench right over here, so I can grab it pretty easily. This is an LMSI card. The problem is that this is a much later LMSI card, and I didn't know this was an issue. So this thing is not actually compatible with this, despite being the same proprietary interface. This card actually spits out an error saying something to the effect of not compatible with Rev 205E, or no, CM205 Rev E or earlier. So this card will not work with that drive, despite being the same manufacturer and the same protocol. They're just slightly different. So that really limits the, let's see, same LMSI card we have for a 386? Probably. That's a much more common one for the internal drives. Actually, it's really rare to find any that have the external port. Almost all of them use the internal port because they were internal drives. So I'll get to the messages in a moment. I just want to finish the explanation here. So that leaves me with possibly two options for control cards for this CD-ROM drive. That would be a Philips CM-153 and a Philips CM-155. I have had eBay searches running for all of the LMSI cards for a year and a half now, and none have shown up at all. That one wasn't actually advertised as an LMSI card, and they didn't put the model number in there right or something. That one didn't show up on my list at CM260. So that's another problem, is that people don't know what they are and they don't list them right. So I'm probably never going to be able to get my hands on an original card for this thing. Well, I'm in luck. There is one other person I know of that has a functional CM100 and a CM-153 card. And they were so awesome as to take some pictures and some really high resolution scans of their card. So today we're going to start trying to clone the card and make a brand new one to interface with my original drive. That way it can actually be used. So that's the goal for today, is to start the process of recreating a CM-153. So there we go. Okay, let's see. Let me catch up here. Okay, let's do this next level streaming. Great stuff. Thank you, Beats Attack. Let's see. What happens if you gift so many subs that the whole channel's are already subbed and there are subs left over?
Douglas McDodgerson says CHEER 100. Friendship ended with phone. Now TikTok is my best friend. End of line. End of line.
All right. So what happens if you gift subs and everyone in chat already has subs? People who previously viewed the stream but are not here will be given subs, and then they'll actually be notified that they're gifted a sub the next time they log into Twitch. So it'll almost always find someone to give the sub to. Let's see. Lucas A22001, thank you for the tier 1 sub and for 6 months. See, I've wanted so badly to have an LED matrix wall that just displays Twitch chat. That would be really hard. You'd need to be pretty high resolution to actually be able to read messages. Let's see. There's someone on here who doesn't stream much anymore with neat pixel grid. Yeah. I think it's a more common idea to do something like that. So, let's see. I do have this bright orange LED sign in the closet I'm not using. You think about shit? Yeah, no, that's probably not fun. Runs on COM port. I mean, if it's just serial port, it'd probably be easy enough to use, but yeah, probably not something that should be shipped. Let's see, I've been using PCFair RS485 hardware with, can't use work. Serial comms would be easier. Yeah, actually, we might find that this thing is RS422, and what's funny is I think I actually have an RS422 card, but I doubt that it's compatible with this thing, but it does actually use serial. We'll talk about that, but it's kind of weird. You have to get back to work. Scott, no last name? All right, see you later. VMTTMV, hello, since your first time chatting. Fire up the replicator. It's going to be a lot more manual than that. So let's see. You wouldn't buy an LSI card. Yeah. Heard Twitch is pushing more ads now. Yeah. Streamers can take control when they're shown. Yeah, so Guy, the way that it works is I actually have a back-end control on ads. I can choose when to run them and how long. I tried, yeah.
JJDB
so,
210SIZHER 100. Da, 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 da. End of line.
Thank you for the 100 bits, JJ. So yeah, actually, I ran the ads. It looks like it just ran more, though. I ran some during the intro. Maybe that didn't count for delaying them, but it says ads won't happen for 56 minutes now on my back end. So that's all I can say, is that as far as I'm aware, that's it. So, yeah. I see 3 LMSI 16-bit ISA cards. So all 3 of those are sound cards, and all 3 of them do not have an external interface. They only have the internal one. There are no sound cards that are LMSI with an external interface. That's a thing. And the interface for the external cards is different than the one for the internal because there's a different number of pins. I think one of them is just no connect, but they actually have a buffer to have the cable be longer and stuff. So, yeah. Let's see. So yeah, what happened during the ads? I don't know, because I don't. I would have to really be paying attention to the back end, like watching it all the time to like actually notice when ads are run. So it's really hard for me to see that. Let's see. What was that? I'd resub, but my Prime sub is still somehow unavailable. even though it's meant to renew today.
FIZZLEW 0 P says CHEER 100% PDR 30,000 and 30 DR 60 30 DR 20,000
lowercase.
25 DR 100,000 and 30 DR 20,000 and 23 DR 40,000 and 25 DR 70,000 and 18 end of line.
It does have to be lowercase. Thank you for the 100 bits, Fizzleop. I will go ahead and rerun that with a lowercase p. I should probably modify the script to allow uppercase as well. Yeah, it is case sensitive. I didn't think about that. So give me a moment here. And I don't know what will happen if two people try and run the same command at once. It may queue them, it may not. I have no idea.
End of line.
That one worked really well. That worked super well. Are we going to listen to this AI voice read this? It's only when there's cheers. That's when it runs. I think I can fix this without too much effort here. Give me one moment. Don't redeem anything right now. All right, save. Okay, it should technically work. I think it should theoretically work now with capital P's as well. David didn't do the cheer. That at least that's what I saw.
David Fenton says CHEER 100. Caught in a bad romance. Caught in a bad romance. Commander and phony NH end of line.
Digital Ice Age, that's awesome. I don't remember recommending unplugging the display cable, but that's cool. Let's see. I think I found you something, not a sound card. So is that the CH-250? Media Vision. If it's Media Vision, it's a sound card. Just, it is. Yeah, because that's a Pro Audio Spectrum. I don't know where the sound comes out, but that's what they always are. So yeah, THFD, it's only when people cheer, and once we get it out of our system at the beginning of this stream, I suspect it will dial down. So if you're finding it annoying right now, you might want to pass on this stream, but it should be. It's Media Vision and not a sound card. I'm not too sure about that. You see that giant connector on the end there? That might actually be external SCSI, but it could also be a breakout cable. Media Vision made some really weird cards. Yeah, what does that cable go to? Why is there a power supply included? Anyway, it doesn't matter. The newer cards, they don't have the same protocol, so it's not compatible. It just doesn't matter. It won't work no matter what. Also, where are you seeing its LMSI? Yeah, that's not LMSI at all. It's just SCSI. That 15-pin port is just for game port. Anyway, it's has huge 3-row D-sub. Yeah, that D-sub is for SCSI. I actually have. Is it just right back here? It might be. I have a Pro Audio Spectrum that has that connector. It's SCSI. Here it is. Boom. So yeah, that connector is SCSI. We can see here the internal connector here. It is a SCSI connector. There's the Zilog controller for it. So that's what that is. I'm kind of interested in that other card and just knowing that it exists. I wish I knew what the pinout of that cable was. I'm hoping someday I'm going to try and like beep out between here and there, and hopefully I'll be able to figure it out. But for now, this is basically useless. Also needs recapped. I keep forgetting to order caps for pretty much everything. Whew. You can see the any 558 game port timer. Ah, okay.
David Fenton says CHEER 100.
Is this the real life? Is this just fantasy? Caught in a landslide, no escape from reality. Open your eyes, look up to the skies and see.
End of line.
That will always be good. That wasn't that good, yeah. So Hellencroft, I may have pictures that are pretty high res on the MediaVision Pro Audio Spectrum page on Caps Wiki. Yes, they are. So you can go to here. TTS is fun. JetJet2112, first off, love the number. It's an actual desktop card running connected to the computer. Oh no, the card we're going to clone. Yes. Yeah, let me get into that. Okay, laptop capture. Here we go. So this is a GitHub repo that I have done, and I'm now realizing, one moment here, I'm going to go to Nightbot and update the code command so you can get to this more easily. Yeah, it does have GitHub, but I want the direct code one. That way we can just get straight there. Let's see, found a website that lists the card as Memphis interface for the Memphis subunit. I have never heard of that ever. Yeah, there's a lot of weird old CD-ROM interfaces, like a ton. I'm actually going to do a video on it at some point. Yeah, JJ, it is actually hardware. It's running right there. There's the deck talk. So yeah, real deal here. All right, updating the code command. So it shouldn't be too bad to do considering all the vias are large and obvious and consistent. Yes, yeah, chartreuse, it really looks like it's going to be pretty, I don't want to say trivial or easy, but it doesn't look like it's going to give me too many problems. All right. So, okay, this now points to the repository I'm currently working on where all of the images are. So, let me really quick here go through what we are working on. Less painful than other cards? Yeah. And all of the parts are off the shelf. Every single one of them. So, let's see. Never say something will be easy. Well, I really feel like this one's not going to have too many surprises. So, I have the files downloaded here. Let me just open this, because I have this already done. This is the one bit of work I actually did this morning before starting the stream, because I figured this part would be just kind of annoying to do. So, the card, this is the original CM-153 card, all right? So if we look around here, every single chip, first off, is Philips branded, because hilarious. But they're all 74 series logic chips, every single one of them. There are no ROMs, there are no weird things. They're all 74 series logic chips, with the one exception, well, I guess that's not 74 series, but it looks pretty off the shelf. With the one other exception, being this, the 8251A, and that's just a UART controller. So even that is an off-the-shelf part. So we should be able to completely clone this card. There is one capacitor here. We can see it's 16 volt 50 or 16 UF 50 volt. On the back, there are some passives. We can actually make out all of the resistor codes, so we're going to be good there. There are some capacitors. I'm guessing these ones are just 100 nanofarad, so that's probably not going to be too bad. That one, I'm not really sure what's going to be, but these ones up here, I'm not too concerned about because they're right under the crystal, so I assume these are going to be part of the data sheet for the UART interface. So we'll probably get recommended values for that based on those. So, yeah. Let's see. Serial line driver, awesome. Philips for the win, Netherlands. Yep. The person who actually sent me these pictures is from the Netherlands. We're gonna see if anyone they know actually has a schematic for this, which would be awesome. Gray ones are in the picofarad range. That makes sense. Vogon's apparently Mapsense was 1K multimedia setup. Oh, weird. With SCSI. Yep, makes sense. MIDI in out. Yeah. Yeah, that makes sense. Will there be any patent copyright issues with cloning this card? No. I mean, no one's gonna go after me. I mean, the Sound Blasters and the Adlib have been cloned, and those are way more desirable cards. This is nothing. This is not gonna be a problem. Gonna be laying out the PCB. If everything goes smoothly, yes. And I actually get to it. We're burning time. So yeah, that's it. We'll be up to the crystal used rather than what is on the original. Yeah, so hold on. The capacitors for the crystal have to match the crystal's load capacitance requirements. So what I'm assuming, again, is that the data sheet for the 8285, or at least one of them, will say for like this crystal value of like 5 megahertz-ish, will probably have specified capacitors for it. So I'm not too concerned about that. The person who sent me these pictures is willing to help out more if I need it. I don't know if they have the capability of measuring capacitors, especially at that value. But yeah, so. Yeah, cloning is fine. You're documenting hardware you already have. Definitely, yeah, I have it. See, crystal caps are rarely not, well, I'll find out when I can start working on it. See, you'd never be able to measure that small without removing them. Oh yeah, for 100% chartreuse. Yeah, no. So that's I'm hoping I don't have to ask them to measure anything else. But yeah, we can see here, all the traces are really easy to see. They're pretty basically laid out. The only ones that are going to be of any difficulty are going to be on the top side that go under the chips. So pretty much kind of like here, these two go under and then disappear. I'm not really sure where they go. If we look underneath, we see vias that don't really match. So this makes me think this one probably goes to here and this one probably goes to there, if I was going to guess. So yeah, oh yeah, I didn't mention it. The GIMP file that's in the repo has already been aligned for all the pins, so these match up, so you can fade between the two and get an overlay of where all of the vias are going to things. So yeah, those great things could be inductors, couldn't they? I don't think so, because typically on a crystal like this, you would have capacitors that are used as like a buffer kind of thing. So yeah. See, crystal caps vary a bit depending on the capacitance of the crystal driver and size, vintage and specs of the crystal. 20 sounds plausible for zero though. Yeah, crystal is going to the, and that is driving viewer. Yeah, yeah. I'm assuming there is a like example schematic for the UART that'll probably show something like this. If there's not, I might have to do some research of just general applications of that UART, see what other designs are out there, just to get a rough idea of what those might be. That's the primary thing though that I may not be able to immediately figure out. Yeah, everything about this is on GitHub. You can go look at it if you want. So there is that. But for right now, what I kind of want to do is I want to get started on going through the kind of ref deses this has. It seems like 7115, 7112. These are the sort of ref deses each part has. I want to go through and ID what every single chip is on here and create a list of all of them, and then start linking to data sheets so I can see what the individual pins do, because that might help for some of the ones where the traces kind of disappear and I don't know where they're going. So that is the current plan. So let's see, or just through hole ones for the clone so it's easy to swap and test. Yeah, I could do that, chartreuse. Definitely. Yeah. My end goal is to have the resulting clone card be as close as possible to this visually, but we'll see. KiCad, yes, it is KiCad. Actually, whoops. I installed KiCad for this for the first time on this laptop, and apparently there's a new version of KiCad now because it's weird. I've never seen it look like that before, so that's a thing. So, or just listing the nets in a spreadsheet. Oh, would it be worth putting every IC into KiCad, then doing single nets and highlight them in GIMP as you wire? Yeah, that's my plan, Chartreuse. My plan is to start tracing over one trace at a time and build up a schematic in KiCad, and then I will figure out which pins are not connected and things like that. I'm hoping that'll make it easier to figure out. I've never reverse engineered or cloned a board like this before, so I'm not really sure what the usual process people take is for this. So, yeah. Dump all the chips in the schematic and then wire them. Yeah, that's the plan. That's why I'm gonna first go through, make a list of everything here, and then we'll start working on that. Actually, you know what? Let's get to that right now. Let's do this. I'm gonna open the README, and I'm gonna start a list of everything here. Actually, how do you make a table in Markdown? That would be kind of fancy. Well, what are we going to do? It's going to be the chip name, the ref des, and a data sheet link. Yeah, it's enough to make a table. Okay. Let's see. Markdown table. Those 78 chips are very common. Yes. Yeah, they should be extremely well documented. W3 schools, gross. Header, yada, yada, yada. Okay, so that'll work. I'm just going to copy that. This sure sounds like usual 2 caps and inverter gate Pierce oscillator topology. Probably something like that. I'm really sure that it's going to be standard size. So it's just pipes and dashes. Yeah, I just need to know exactly what pipes and dashes. I haven't done that in a while. Okay. Parts list. Okay. So we're going to do ref des, part number, and data sheet. All right, so let's get started here. 7104, so it seems like bottom right is the start. So 71-1. 7101. We are officially beginning. PC 74HC T 245P. Alrighty. Only 50 minutes in. Yeah, that's pretty usual for me, chartreuse. I am not speedy at getting into streams, especially when I got something fun like the deck talk. It's going to take my time up here at the beginning. So let's see. Can I just get straight to... You know what? I want to try something here. Archive.org. I don't usually search for data sheets on archive.org, but I feel like these are probably all there. AppJa, I'm hoping that's a good pronunciation. All of these are Jelly Bean parts. Every single one of them. The UART is the most complicated part. So I know all of them are going to be like, oh, it's just that. I don't know what these all are offhand, but I want schematics for them. Well, like pin diagrams. That way, when I go to start wiring up everything, I can use that as like a second look just to make sure everything is connected right. So, yeah, probably need to get rid of the T too. Or do I need T? Don't add the Philips specific. So, okay. Serial driver in New York might not be in KiCad. Yeah, that's not a problem. I can make the parts. I've done that a bunch. HC and HCT are different. Okay, good to know. Might get better results if you chop PC off. Yeah, I hadn't done that. Anyway, let me throw that back into archive.org. Aha. Oh, actual Philips NXP. That's hilarious. Okay, we'll go with that. So copy, and back over to here, and paste. Alrighty. I like the idea of linking to data sheets in archive.org. So you have chips sold on DigiKey Newark. They will have a link right to the data sheet. Yes, yeah. I'm hoping I can get all these on there, or else I'm going to have to start playing eBay lottery, which I don't look forward to. So first Google result was also correct from TI instead. Oh yeah, I'm sure. I kind of want to. Well, TI is pretty solid as far as link rot. I was just trying to make sure this doesn't link rot immediately. So PC's on for 2.4. Okay. So UART and line driver might be the only eBay ones. Maybe. Yeah. Oh, wait, I was going to search for that on archive.org. Oh, that one is not. Weird. HCT244. Yeah. Huh. All right. Plain Google. Go with the TI one. Boom. Octal buffer. Okay. So would it be worth just doing quick OC, OCR? I'm not that worried about it. It doesn't take me too long to type in the part numbers. So I don't think that I need to do that. What on earth is going on with that? What's with the Google URL in there? Wait, reference URL? That's weird. We can get rid of that. Yoink. Okay. Double check that works. So there's not many unique parts on the board? No, yeah. It's I'm just gonna take the time to document everything. It might drive some of you nuts, and I'm gonna like waste so much time on this, but I really want to just have this be as well documented and easy to navigate as possible, because I've never done a reverse engineering like this before, so I just want to go through it the slow, painful way to make sure I have everything I need. Yeah, I did remove the tracking. Oh wait, that's also tracking? Ah, okay. Boom, done. All right, so this one is 04, and it is PC74, HCT. What is the T? So I feel like that's a thing there. Three? What about 3? 38138. What did I mess up? 3. TTL compatible input levels? Oh, I thought that was HC. Okay, then I apparently don't know. HC is CMOS, HCT is TTL. Ah, oh, okay. Let's throw this in there. Look at the end of the PDF. Oh, good catch. Thank you. All right, we have data sheet here. Ah, the actual Phillips part too. Sweet. All right, continuing on. Oh, 05. And wait, is that the same thing? 3838. Yep. Okay. Well, that's easy enough. Next. Wait, why is it 7118 and then 7106? That's all right. I'm gonna go with that one. All right, 6. HC, no T, 08. Is there something I have wrong here with the one Hellencroft that I just had up? Ooh, sweet. Bunch of them there. Like, this is an acceptable data sheet, right? The one that I linked to on archive.org. It's just my preference. I would prefer to link to archive.org. Oh, you're just finding some that are different. Each one of those are different ones. Okay. 244. Yeah, that one. Okay, now I'm seeing. So that would be slightly more accurate. Uh, 138. Do I need the latest version? Wouldn't a vintage one actually be slightly more appropriate? I mean, 2003, it's not that vintage. It might suck, I don't know. They're all going to be roughly the same, but yeah, next variant ones are modern links. They should all be the same. All right. 20 years old, yeah. Okay. Oh, I like the fact that they scraped it from the manual scraping site. That's great. Okay, that one's not a part. Wait, what? X2? What? X tall. Oh, okay. They called Jumpers X. Okay, that one's X5, so X3. Weird. All right. All right, 74HC32. Okay, this is the one you guys said that there's a billion of. This is 7107. Oh, you know what would make sense is if I just did this. Copy, comma, paste, and then got rid of the redundant ones. There we go. Well, I guess I can use these. Since they're going to the actual parts producer, I'm not too concerned about the link rot. We'll probably redirect if it does change. There was no 706. I'm pretty sure these are like grid-based, except for that one weird one, the 7118. 7107. It is an HC non-T32. And then URL. All right. So does this mean the controller did not work? It did not work. I'm a cat. I bought it. It's sitting right over there. I tried it. It says something to the effect of earlier than CM-205 Rev E not supported or something like that. So yeah. Yeah. You can also change URLs so the part number, as they're all the same. Does look to be, as long as they have them all. They probably do, but as long as they have them all. Okay, so this one, actually, we do have a part for. I am going to recommend it be added in. So this is a picture, this is the picture they actually put into the video when they made their video. And they specifically mentioned this, that this part is in a socket, and it is on the card that they have in their computer using. The scans that they took and the pictures they took to send me that are the really good ones is actually a spare card they have, but it is missing that chip. Whether or not it's needed, I don't know. It could be the difference of the external port functioning or not, though. So I'm going to put it on there. So yeah, that is DS to 6. Oh, W, they need the chip? Yeah, that's what I'm guessing. Yeah, so what I'm guessing, I'm a cat, is that the older ones are, the older drives are not compatible with the newer controllers, is what it seems like. 32CN. Okay, so that is, hold on, I messed that up. LS, that looks like, yeah, that's it. Okay. So this is 71, 71, 21, blah. Data sheet will be located. I think I should go ahead and actually put this in there too, but just not fill it in. (7118). Socketed chip is also labeled on the PCB. Oh yeah, it is. What do you know? I'm still guessing it goes to the external interface, because it's definitely a big thing that not all of the cards have the external interface. So for some reason, that's like an option. Oh, there's some Motorola chips. Interesting. Also, I don't know that I've ever seen that Motorola logo on a chip before. That's kind of cool. So MC74HC 595. Wait, 595. Is that a shift register? Hey, I know one. What do you know? Also, National Semiconductor, the 26 chips. Oh, is that what those are? Ah, yeah, there it is. Okay. 7117 is also that. 7117. Serial in parallel. Yeah, shift register. Yep. Maybe they figured that it blows up a lot due to ESDs. Maybe. It could be it. 7116 as well. 7116. Is there going to be a fourth one up here? No. Okay. Well, that's interesting. Wonder how that's working. All right, so we got that. Those two, I believe, are different. LS32, LS31. Yeah, so we won't be doing that. You know, it kind of makes sense to just mark them all down and then go grab all the data sheets after. So let's just do that. Okay, so this is, I'm just going to copy, paste that, a 20. These are labeled all weird on this side. And that's a 31. Is that the only difference? 26. Yep, okay. X2 is for Octobus driver. All right. To me, what they actually are doesn't really mean a whole lot or make a difference, what the parts do, until I get into the schematic side. So I'm not really concerned about what they are. I'm not going to even bother documenting it here. This is mostly just so once the card is done, people can order the parts and then figure out what the ref deses are. That's what I'm doing here, but I'm also linking the data sheets for the reverse engineering process. What's going on today? Wesley, we are making a new card for my Philips CM-100 CD drive that will hopefully allow me to use it finally. I have a really nice scan and set of images of the card that should make it possible for me to reverse engineer it. I've been trying to buy the card and it's never shown up, and I tried to get a different one and it didn't work. So that tells me I should really just make this card, because I'm not going to get one and none of them are compatible. So, and hello Ozone. Okay, so 7109 here, 7109 is PC HC 368P. Okay, get the data sheet later. See, oh boy, hardware reverse engineering. Yeah, kind of. See, when was this card originally made? 1985 is when the device it would have shipped with was released. So there might have been in production slightly longer, but that's when it would have been made. So. There are not schematics. Yeah, I am going to be creating the schematics. I'm going to be doing the whole thing here, to just pictures to actually reproducing one of these. Yeah, that's what it seems like, Charters. I agree, it does seem like that. Mine's going to have date codes from the 2020s, potentially, so that'll be kind of funny. What am I doing here? Okay, 368, there's no more of those, right? No. Okay. So 125 is a bunch of ones, and HC125P, 125. See, how expensive are those components? Probably not that expensive. I'm not expecting this card to cost me more than like 50 bucks to make. See, if you can't figure out all the connections and the owner can't help measure stuff, they can send it to me because I'm also in the Netherlands. That's good to know. Do you have the hardware to measure those capacitors if I have a problem with that? Because that's the only thing that I'm really concerned about. Yeah, I think they have the capability. They actually mentioned you have all the tools. Awesome. They mentioned that they're actually working on reverse engineering a PDP-8 card. So I suspect they'll be able to beep out traces. But again, the measuring capacitors thing is kind of weird. So they may not have that. I don't know. Let's see. All right. Yeah, Starrock, I know what you mean, but I don't have enough familiarity with them. I'm not going to learn it right now for this. I know what you mean, though. But yeah, Jelly Bean logic. It should be very simple. The Mechatronics has it right there. Yeah. See, I have another controller somewhere, I think, that came with a CD drive. Let me check, see if I can find others. All the others I have are CM-260 cards. So I think it has to be 8-bit ISA. That kind of delineates what the chip is.
210 SIZHER 100.
Do I feel lucky? Well, do you?
Punk. End of line.
That's one of the better uses for the too many cigarettes voices. Yeah, I am really excited how much standard logic there is on here. It super lucked out with this being so easy to figure out here. Oh, 7474. I somehow have never seen that before, and I am amused by it. So that is 713 HC 74. Just testing out some commands from the manual. Ah, okay. Also, thank you for the 100 bits. It's really hard for me to remember to say that now with that, because I'm just the deck talk is so much fun as it is. All right, that is actually slightly difficult to read. Is that a 0? I'm pretty sure it is. So 7110. I do not have one of those marked previously, so I'll go here. 7110. And then C04. $7112 is 74 again. Okay, so actually I can put that here. Makes you wonder why the driver couldn't be made to work then. Anybody try hex setting no opted drive version check? I think the protocol is different from what I've heard, Wesley. I don't think it just doesn't want to work. So, David, we're in the slow part where we're grinding out what the parts are on this. So I'm creating a parts list, and then I'm going to go through and get the remaining data sheets that I don't have yet, and then we'll start actually figuring out what the connections are. Where was that? Okay, 32, 7018, where was that? The 32, okay. Wait, did I? No, okay. 7108, and then 74, 712, and then there was a 24. Okay, that one's weird. Let's see, I wouldn't bank on any of this being fast. Yeah, it's 115 kilobits per second CD drive. It is literally 1x speed. 4024. Oh no, the reverse engineering process. No, I suck at this. So, yeah, I've never done this before. Yeah, so. What? 71,424? Yeah, I got that, right? Wait,
David Phantom says, okay, then be back in another 30 minutes. In the meantime, CHEER 1500. End of line.
Thank you for the 1500 bits. Wow. Skip the 74 in the name. Oh, that's what it was. Oh, okay. Thank you. 74. Have you used serial device sniffers to intercept a proprietary program commands? No, because I don't have a functional card. I assume that the protocol is different with the new card, so it tries to talk to this thing, and then this thing just goes, oh, and then it sends garbage back. So I'm not gonna be able to get anything out of it that way, I suspect. I have forgot 74 on a lot of these. There we go. Forgot it reads out when you cheer automatically. Yep. Search, replace. Well, there wasn't too many. I think, okay, that's, oh, just 7114. Okay. That's the same thing. 7114. And now it's just this, and then that's it. $7119 is P82 8051A. There we are. Boom, boom. Okay. You have 7105 in there twice, do I? 7105. It's there. and there. So I just need to get rid of that line. Okay. Don't forget the crystal. Yeah, the crystal and then the passives that I can get. That I was going to get on to that down here. So xstall is 4 point something, lots of megahertz. 4.9152 MHz. There won't be a data sheet for that, doesn't matter. And then C only, the one C, is there a ref des over there? No ref des on the cap, okay. Ref des, big cap. That is 50 volt, 16 UF. Anybody recognize the xstall frequency? I don't know. What does an Arduino actually do? An Arduino is a microcontroller. It has an EEPROM on board, and technically it only executes machine code. So you would compile a program like C, and then it will store the opcodes onto the EEPROM, and then when it starts up, it will just run the code that is stored on it. So it's just a bare microcontroller, but Arduino as a concept is a whole development environment based around trying to make it as easy as possible to use that. So yeah. Okay, so that side looks good. All we can actually do, you know what, let's do that. Connectors. X5 is how many pins? Probably 8. Yeah, 16 pin. 16 pin. All right, you know what? I'm going to do 2 by 8 pin IDC. And then there was X5 over here, right? No, X2. X2, 2 by 4 pin IDC. And then there is the rear connector, which is X3. X3. And that is 15 pin D sub, 15 pin D sub, which is really confusing because 15 pin, not Y3? Oh, it is Y3. Why is it Y3? It may be running much faster, probably 3840, 400 for the control, something parallel faster for data transfer, or 50 kilobits per second. Yeah, that is the operating speed. Okay, so there's that side now. So let's go to the other side of the board and mark down all the resistors. Oh, these don't have ref deses. Ugh, gross. Oh, that sucks. I might create some ref deses for these because this is blah. Also, this is mirrored, so yeah. Leave SMD stuff for after you started the schematic. I guess I can do that. Yeah. Yeah, I'll do that for now because I don't feel like writing all that down. That looks like a pain. Okay, I'm going to save that. Let's get the schematics. The data sheets. Okay. So, yoink. Paste. Nothing for that. All right, go generic. Next area, probably not going to do much better than that. Download data sheet. And yoink, that was, wait, what? That's not the same part, is it? No. There it is. Okay, boom. All right, should we just see HCO4? Will that just work? 04. All right, let's just scum the URL. 125. 125. Seven, 4. Two, 4. Oh! Oh, that's because it's 4024. Der. 40. Still no, though. Okay, let me see here. There it is. Different URL. Alright, 74HC595. I definitely have the TI version of this datasheet saved somewhere. But we'll just grab this, 595, boom. Although I think that one was Motorola, so, doesn't really matter. Alright, these are different. I don't know what the deal with those is, so we'll just Google those. TI, that'll work. Oh, their URL sucks. Let's just put a 2 here, and then boom. Nope, that didn't work. Yeah, Wesley, it is very strange. Yeah. There was an NXP plant nearby where I am, and I watched it get rebranded over and over. It's now on Semiconductor, if I remember correctly, actually. Oh, you worked there. Interesting. Oh, that's funny. So yeah, you know exactly what I'm talking about then. All right, let's get rid of all the garbage. Boom. Boom. All right. Don't need data sheets for that stuff. And let's go for this. I looked for this before. Gonna need a, yeah, it's, oh wait, AM? Is there a difference? I don't know. I'll just grab it. Drivers RS422. Yeah. Okay, this. We need a data sheet. You know what? I'm gonna archive.org that first. Looks like probably no. All right. No difference, just TI, AMD. Wait, is TI owned by AMD? Huh. It was like, what are we calling this for this week for a bit there? That's hilarious. I will just take that. I think I went to that URL earlier. I am going to... Oh, I don't have the Wayback plugin installed. I want to make sure that's actually archived. And it is. Okay, so that one's safe. Boom. Okay, all that's done. I am going to go ahead and commit that now. So that's not what I wanted. There we are. Git status, git commit -am, add parts, git push. All right, so now we can go back here and everything is broken. Okay, let me fix whatever's going on. Happens after the manual lib one. Oh, does it not like having the spaces? Oh, that'll probably do it. Save. Fix parts. F5. There we go. All right, that's fancy. I like that. Okay. So this is incomplete because we still need the SMD parts, but that's good enough for now. That's screwed up. 7109. Why did that get messed up? Sure it's not 16 and not 10? No? Seems like an odd... No, 16 US is pretty standard. 16 is very standard. It's really hard to tell. Oh, 16 volts would be standard. Yeah, that's right. Let me look at the other pictures. Image ref. I don't think we can see anything on this. No. It might be 10 UF. That's the one I think I'm referencing. I don't know. It's probably just that little bit right there that kind of threw me off. They're different pictures. That's really hard to tell. I bet it won't matter which one I pick. So I can probably just go with 10. I really can't tell. I'll go with 10. I'll update it to 10. All right, one more time there. Oh yeah, I should have fixed that too. Dang it. Let's just grab one of the Xperia 368, right? 368. Okay. Copy, paste, boom. Like 35 commits called fix parts. All right, there we go. Now it should all be good. F5. And, yep, that all looks right. Okay, so we've got that. Now let's start the reverse engineering process, I guess. I'll bring this back over to here. Okay, so how do I want to do this? Again, I've never done this before. I'm gonna get that commit count up for better coding. Yeah. You didn't commit with user story reference. Yeah. It's just 8-bit card, probably not very helpful. It's a highly integrated chip on there. Is that CM-153? Oh no, that thing is super weird. What on earth? It's a CD-163? I've not heard of that thing. That is strange. Weird. Yeah, I have no idea what that is. It looks like an LMSI. All right, yeah, on that, I'm gonna be right back. I wanna go look for one thing really quick. It shouldn't be too hard for me to find it. Let's see, interface, yada, 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 bunch of stuff. Oh, that's 485 that I have, not 422. Oh, okay. I thought I had a 422 card, and I was gonna just see if it like just straight up plugs in, if it's D15 port and all that, because that would be hilarious. Doesn't look like I have a 422 card though. Yeah, okay. So I got 485 and 488, of course, but not 422. Really thought I had a 422 though. Wonder if I do and it's just somewhere weird. Dump all symbols, schematic roughly the same place as the actual board? Yes. That card is also in this tweet. One moment. Oh, interesting. Okay. What year is that? There's probably more 422 going on. Almost certainly, yeah. I was just curious. Huh. CD-ROM multi-session. That's hilarious that it specifies multi-session on the front of the unit. Anyway, first impression of PCB images, driving, probably something like that. Okay. Yeah, so I guess, yeah, start out by making a schematic, and then I will start drawing on here to track where each pin is going, and then as I cover each trace, then I will know. Okay. So let's get KiCad open. What is this one? Oh, that's nice. That's the first pinout of LMSI I've seen. Maintenance for drive only. Interesting. Only tag for your stream is English? Yeah, I have no idea what the tag does, so I just don't bother. I mean, what am I going to tag this? Like CD-ROM? I don't know. Pro tip, get a ISA card from here so you can have PCB outline and ISA stuff already. Oh! Wait, where is it? Oh, wait. You just want me to use one of his as a starting point. Doesn't it? I thought KiCad had, like, just an ISA card already baked in. Like, the port. Yeah, maybe I will just start with one of those. Import the PCB file for that. Actually, I can just copy paste it, I think. So I say finger part, not the board outline. All right. Let's see. I think lib, is that what I'm gonna want mostly? Oh, I don't like it. He's put so many 4 series stuff in there. Yeah, I can do that. Okay. Nope, not the schematic. I don't want to open the schematic. Yeah, copy default. Load without cache file. Okay, there isn't one. Oh, that's gross. Hold on, we gotta fix this first. Excuse me, how do I... There we go. There we go. Better. Okay, grid's a little... Oh, it's bright because 4K. Wow, I've not used this on a 4K monitor yet. Man, it really shows a lot of dots there. Starhawk, I appreciate the enthusiasm. It's just right now I'm not at that point yet. So, yeah. Scaling, yeah, no, it's that it can actually render all of that still at that point. I've just never seen that. Oh, yeah, for you, it's going to be weird. Yeah, you're going to get all kinds of moire nonsense going on.
JJDB 210SIZHEER 100 going full throw to test something. Sorry. 1.
30 seconds, I think. Yep, it's gonna work. Oh, that's great. Oh, wow. Yeah, Cody, cheers go to the deck talk. Wait, that's way more than 30 seconds, isn't it? Oh, that's...
Two.
Oh, that's awesome. Oh, that's great. I was wondering how long it was going to take for someone to do something like that. I thought rate was going to be the first thing. Oh, wow, that's awesome. All right, well, we'll just let that count for a while. We'll give it a few minutes here now, Cody. I guess we got to get through this. Oh, that's an interesting one. I don't know what it'll do there, actually. I think let me double check. I'm pretty sure I do have it reset the rate for punctuation. Let me just double check. Yeah, PP gets reset correctly. So after this, it will be normal again. I am really curious, though, if it's going to actually play your next message. I have no idea. I don't have any, like, queuing built in, and the API uses callback functions. So I suspect it tried to run the callback function. But it may also just have the serial buffer on the Linux side that will then play it afterwards. So I really don't know.
5.
No, it's still got to do the end of line. I don't reset it before the period before end of line or after. So it's got 2 more periods to get through still. We need a timeout on deck talk. Yeah, it just kind of doesn't work that way because the length is so variable. Oh, that's amazing.
End of line.
There'll be 1 more period there, and then it will reset, and then we'll find out if the second one goes through. Ooh, is it not? That's disappointing. Okay, well, that's good to know.
JJDB 210SIZHEER 100 a second test.
Oh,
End of line.
that's really good to know. Okay, so it buffers them. Awesome. That must be happening at the serial side on Linux rather than in my code. Because I bet the code's just spitting all the serial out that it can. This does have proper handshaking for the serial interface, so the deck talk should be saying, hold, don't send me any data yet. Oh, that's excellent. Yeah, Dratinio, I don't have, like, serial reads back from the deck talk, but the handshaking for the signal should be doing it. How much did deck talk cost? Don't buy one of these. This one was super expensive. This one was $300. I don't recommend that, and I don't think that they're worth that. I mean, it's awesome, but this is more money than the last intact Deck Talk Express sold for before the one I bought. So, yeah. Yeah, there is a demo app on archive.org, and it does work. I did mess around with it after I'd bought that. Is the handshaking actually enabled on Linux? I don't know, but it does seem to be working. So, yeah. Oh, JJ, there's also an actual live JavaScript deck talk emulator that you can use in archive.org that works. See, if not, you can run it with just TX and Groundline, probably. Yeah, I've heard Moonbase Alpha does. I've seen a bunch of examples of things from that. That or DeckTalk just finds some space for serial buffer and it's 1 megabyte of RAM. I think it says in the manual it only stores like 64 characters or something. I don't remember. The RAM might just be for the phoneme stuff. Is there a cheap knockoff that's hardware based? No, not that I'm aware of. Oh wait, actually I think there was. Wasn't there like some modern open source one? Oh yeah, good call, Huncroft. Well, didn't you want me to import their stuff first though? Like actually just throw away the project I created and open the Monster FTC? Is that basically what you were saying? I mean, I can do this and start adding parts. Okay, well that's gonna suck. Open their project. Okay, yeah. So we're just gonna toss mine in the bin. Should be in downloads here. Okay, and it's gonna want it updated to its thing. Ooh, fancy pants. Grids. Okay, so yep, there's some stuff going on in there. So you might have to omit the HCT or sub it for LS to get the signals. Yeah, J Metal, I am not going to present as well on stream as I could actually do this off stream when I'm not focusing on a bunch of different things. So I am familiar with all this stuff. It's just on stream it's really hard to focus on all the individual things. I'm going to change the color on that because that's impossible to read. Just give me one moment here. There we go. KitKat has them listed in the 7X library. Makes sense, yeah. Okay, so yep, there's that thing. Go ahead and close. It always saves your camera position. PCB editor. Okay. So what we're gonna do is we're gonna cheat and use this basically to get the ISA connector, I guess. For grins and giggles here, view 3D viewer. Look, mods PCB. Does this not have the edge cuts? Because I was wondering how I'm going to get edge cuts made for the bevel. Well, AppJet, I've never done it before, so I'm maybe not the best example on how to do this. So yeah, ISA, but also a holes for backplate mount, possibly. Maybe, yeah. Cut is just at the PCB house stage, so I like give them a note like bevel this? Is that what that'll be? Because I've never tried to do that before. Just specify bevel to the manufacturer? Okay. Oh, the 3D viewer has gotten so good. Like the sheen on the metal, it's like just bananas. Anyway, that's not even with the ray tracing mode. Boom. Woo! Totally don't need to do this, but you know. Well, it's not RTX, neat taste, but yeah. Just do him with the by hand. Yeah, I was considering doing that. Anyway, they'll figure out where the edge connector is. Yeah, I just make a note or something. All right. Turns out there's Deck Talk Demo EXE that you could run Wine, probably. But I was only ever interested in if I had real hardware, because to me that's the only way that it's fun to do it on the stream like this. Only if it actual real-time Vulkan ray tracing, yeah. Toggle you set during order. Oh, okay. All right, well, okay, I'm gonna do discard changes. I'm gonna do this file, save as, all right, and then I'm gonna go to my project, home, get, and I'm gonna start hacking stuff out of the thing, the schematic. I get that, Starhawk. It's yeah, okay, so this is one of the big things that we need, so we need to leave that. Probably all his pinouts there too are good. Seems Foon is also busy looking at PCBs full set for Logica. Yeah. Who's your board manufacturer of choice these days? I don't remember. I don't have an opinion right now, actually. Other than probably not PCBWay. Okay, so that's an HT. You know what? Here, I'm going to do this. Is there a project library right now? Video? No. Sure, Zigbee stuff? Fancy. I am not sponsored by PCBWay, and I don't plan to be. I have been in the past. I don't plan to be again. They don't have the respect for copyright that I would appreciate. They would. You have to set project library first. Well, I could, yeah. I was just trying to see what all was in here already. So they got a 138, and that's not in there. HCT. Oh, it's 74A? What? Just search, yeah, 138. It's not there. I don't think I need the star. Or maybe I do. That did change results. I still don't see it. Did they modify a part to get that? An LS. Did they just rename it? So they just rename the part number from that? It looks like that is the same as that. Okay. Bomb invention? Hello. Since it's first time chatting. Elbow cam, was it? Yeah, if it loses track of my face, like if I'm leaning into this, yeah, it'll do that. Stupid 4K. So, all right, well, if we can just use the LS. LS is just a different voltage level, right? Like that might be, I have no idea. So, yeah. Less hassle. Oh, for sure. Just found a picture of CM-153 controller. Looks almost identical to mine, but probably has 12 volt power for the drive included. Ah, interesting. I'll look. Why not? Numbers right. Rename Logic family. All right. That is very similar. We can kind of make out what's on that without taking off the sticker. Because I'm wondering if that's a Philips proprietary part, because that doesn't look like it is. That might be compatible. I don't know. Are those inductors though over there? That's a little weird. Yeah, I don't know. Anyway, okay. Oh, okay. So it's basically FPGA'd on there, or it's CLPD'd or whatever. Yeah. All right. Okay. Go back to this. All right, so I think I have some 138s in here. Yep, 138. So we'll leave that part for now. Let me put that over there so I can get to it easier. So don't rip that out, but I'll rip out all the logic in a little bit here. They got a bunch of 138s. I'll figure out how many I need. That's a dip switch. We don't need that. My config jumper is slightly different. We'll remove that. This is 24 megahertz crystal. I can add in a crystal again. That won't be a problem. Okay. Whatever that thing is, we don't need that. So, boom. Floppy controller, I guess. Those are floppy headers. We definitely don't need all of that. And the floppy controller we don't need. Settings. Ooh, that's fancy. I like the documentation in schematic. That's nice. Let's get rid of that, though. Okay, and I'm going to have to remember to actually modify all this stuff now. I'm starting with not my schematic. Well, I'm going to leave that so I can copy-paste it. Yeah, BIOS extension ROMs, that's ROM. Yep, and jumper nonsense. EEPROM, flash, no, don't need that. UART, ooh, that's almost what we need. All right, and then bypass capacitors. I prefer putting those by the chips. So I will be doing that. That stuff out of there. All right, and then just to make sure it's clean. Boom. Boom, okay. So, we need two 138Ps. We'll delete that top one, and we'll delete probably that one. This. And the wiring. What's with the wonky lines? Is that to indicate a bus or no connect? I don't remember what the blue thing is. Oh my gosh, it's so tiny. X's or no connects? Okay. What does the weird line indicate? I don't remember that. Line is inverted output. Okay, so I probably don't need to change that then. All right, I'm going to assume those are the same. Let's see, it's part of the symbol. Yeah, I knew it was part of the symbol. It's just I didn't remember that. Rename part numbers? Yeah, I will be in a moment. These are 7104. 7104. Illegal reft as. Fine. You. 7105. Dr. Hugh, thank you for the gifted sub. See, sometimes they use a circle on the pin to indicate inverted. That would make sense, since that's how, like, logic symbol inverters are denoted. So your list is AHC, but you can change them to HC or HCT. Okay. Well, they're HCT there. Whatever that means. See. Or bar on top of the pin name. Yeah, that would make sense too. Okay, so We're about to do our first thing here. So 7104 and 05. Hey, excuse me, it's these two. Okay. Oh, they go straight to the ISA bus. Okay, well, that helps. Now, if only I knew what these were. Are these labeled as like A whatevers? Oh, that's probably going to make this really easy. Except they don't go up to 32. What? A31 and A22, but this doesn't have it that high. What? No, put all chips on the schematic? Yeah, I guess that makes sense. All right, and I gotta place them where they are roughly. Yeah, give me one moment. Okay, these two are down there. A means A-sided connector, so pin 32. Oh. Wait, so B for the back. I know. Rotate it 180. Are those the ones that go into? Yeah, that would make sense. Oh, okay, then... Wait, I'm still lost here. Data liner to the back of the case. Oh, I'm looking at the pin names for this. Okay. Oh. So... I'm an idiot. I was reading these, not the pin numbers. So, okay, so 32... I am going to put all the chips on. I was just trying to figure out what on earth those represent, because I don't know the ISA pin out by hand or heart. Yeah, let's I'll just put the rest of the chips on here first. All right, 244 and 245. 244. Do 74X HT. Ooh, we don't even have to do weird stuff. Just get the H. Boom. All right, so it goes there. A 245 74. We don't have an HT for that one. Sad. Oh, okay. Yeah, there we go. Boom. Then nothing else over there. Okay. A32 like D8. I don't know. I just don't know. 32P. Okay, so I suspect there's going to be a lot of stuff that shows up for 32, so I'm going to do HC32. Really? What? Alright, well, I'll just go down to the 7432 is, okay, so quad something symbol thing. So, okay. So that's there's gonna be a lot more things I gotta put in the schematic though for that. Like that's just one, yeah. Oh, what is that? Is that power? Gross. Man, it's just gonna be a whole bunch of those. I hate that footprint. Or schematic symbol thing. Ah. Put all the power symbols for gates in the corner. Yeah, that does make sense. Get out of there, stupid power thing. We can see 77432. Nope, not combined. Different units. LS32. There's 322, but yeah. Well, it worked better for like actually laying out a schematic for the logic, but for like a reverse engineering thing, it's going to be annoying. Also, I'm forgetting to update the ref des. One moment. This is 7106. I assume that's going to change across all of them. Why does it not propagate? Are you kidding me? Wait, it shows up there, though. Why didn't it update it? Tools. There are refresh ref deses. Make a custom symbol. That honestly takes a long time. It's not worth it. Why doesn't it refresh? That's really annoying. All right, I don't know. Oh, wait, because I'm an idiot? No. 706. After the reverse engineering, you want to shuffle the schematic around and make it... Yeah, I will for that. Yeah, I guess. It's not 6, that's 8. There is no... Oh, there is a 6, it's that. Quick lib. Oh, that's interesting. Huh. I'll have to keep that in mind. That would work too. I don't really want to get into the project management library side of this. That's not fun at all. Like, it's really terrible. 7107. Why is it adding an E at the end? 8. And then none of those update. Just, okay, fine, whatever. If I move it, maybe? Will it? No. Whatever, I don't know. It's dumb. Alright, let's just leave it. And I need one more. Right, 3-2. Oh no, that's a 7-4. Is there only 2 3-2s? Yeah, there's only 2. There's more 595s than anything else. E is part of the chip, A, B, C, D. Oh, okay, that makes sense. I still don't know why it's not updating the ref deses. Wait, that just worked. Oh my gosh. Okay, 7107. we all saw it. It was not working before. Now it's working, I guess. Hope that was right. Yeah, okay, now 7018. Sound like it'd have different reference designators because it'll all be the same physical part on the board. Anyway, I'm complaining a lot. I don't really mean to. It's just... I wish things were sometimes more sensibly done. No, I know not all use cases are the same, though. Okay, so that's 7113. Yeah. 7113. Copy. Boom. Okay. Rumple in the Bronx, thank you for the Prime sub. Oh, excuse me. Oh. No, but the sensibly done, I wish that it wouldn't make me manually update the reference designator for each part individually. Once this is put onto the PCB, it can only have one reference designator because there's only one physical part. So there's no reason that updating one of these should not update all of them. All I'm saying is that the reference designator on there doesn't make any sense. It should update. The separate parts, I understand. I get that. For this particular use case, it's kind of annoying. But for normal use cases, it makes sense. No. The split parts, I get. I'm not going to complain about that. Much, I mean. Okay, so we're going to add dip. Where is it? Con. Wait, where'd the con section go? Okay. Just go to that directly. Connector, generic. I need a 2x4. Yep. 2 rows. What is this weirdness? Why are they... Okay, sure. Sure, whatever. Boom. So you could have 8 gates, can't guess what 4 you want, with a, hold on, but you could have 8 gates and it can't guess what 4 you want in a single chip. These are all associated to the same footprint though, when you go to like lay out the PCB. So these 4 are always associated with this one part here as one physical part that is going to tie to the footprint. And that one footprint can only have the one reference designator. So I would assume that all of these should share one reference designator at all times, because the ref des is most important for the PCB. Okay, and we're going to add the 08. So you might want to move a gate from one physical chip to another without laying out the board. Okay, but you would just like you would just move the gates in the schematic around like that. You wouldn't just change the ref des, because that's not going to reassociate that gate though. Like you would just, yeah, you have to give them the same reference designator for them to be associated together. It's not by default. Oh, so they aren't associated until that? Oh, that's super weird. Oh, that's awful. That's how it's done? I don't know. This seems like fine technical details. I'm done with that that whole thing. Let's just not worry about it. Also, I think I want tab. Yeah, there we go. That's way better. Okay, so that is physically above that. Good. Now let's go with one here. We need a 74HC08. Does not exist. 74 LS. Oh wait. Oh great. So this is a 7-1. 7-1-106. Okay, next one. Oh my gosh, it's really hard to get these split in a way that I'm happy with. $595. We're gonna have 3 of those. Okay. That one, I think, is an integrated chip. $595. Why is there a little bug in here? Go away, little bug. Alright. 74 HCT. Is it? Yeah, it's just HC. Okay. Oh, sensible chips. I like these. Okay. Copy. Excuse me. No bus selected. Isn't it just C? Select. Move. Copy. Is it Shift C? How do you do this? Did they change it? Oh, they changed it. Oh. Okay, never mind, I guess. Weird. I mean, it's not weird. They changed it to the normal shortcut. Usually you have to select it and then just press C. They changed the 1-key defaults annoyingly? Alright. I mean, I understand. They were weird. So, changing it to something that's more intuitive makes sense. Yeah. I knew it already. Okay, LS 26 LS 32. Wait, is this the same thing as that other one? Is this? Is that what that is? Need 2 streams for dual monitor? Yeah, I know, right? This single monitor stuff sucks. What's worse is I'm doing it in 4:3 because I actually have the chat up on the laptop over there. I just have it cropped out so you guys don't see it. So I have even less space. Oh, okay, so they are different parts. Probably have to make the 2.6 LS buffers. Sweet. 2.6 LS. Yeah, that doesn't exist anywhere. Okay. Oh, fun. Your knowledge is
JDB 210 SIZHEER 100
NS6022 VRR 6024 GAL 6027
Oh!
AH 6024 Jet
Yep.
25031 V100
You forgot the percent P.
30,031 30,000
Oh, at least it'll buffer it.
P100 NN 6022 VRR 6024 GAL 6027 NNAH 6024 LED 25,000 and 29 T100 YU 40,000 and 29 Dow 30,000 and 27 and 10,026.
End of line. JJDB 210 SIZHEER 100
Never gonna jam you up, never gonna let you go.
End of line.
That was pretty good. That was pretty good. Yeah, 8251. That's a good check. 8251. Oh, that sucks. All right. Yeah. So we're gonna have to make. Definitely gonna have to make that part if we can't find one, which means I'm gonna have to do the library nonsense. Only wasted an hour of the afternoon. It was an hour well spent, though, wasn't it? The end of life is an acceptable substitute to exterminate. There had to be something to end it, especially just because I don't. The way that it works, I had to have some text at the end in case. Also, JJ, that oh, did we have? I think did we have someone do a No Strangers to Love at some point yesterday? I feel like we did, but I think that one was way better. What you did, JJ. See, There Are No Escape. Yeah, I think it's quite exotic. Everyone seems to have standardized 8250s. Ah, okay. All right, so I was thinking for this part I'd just cheat and not do like a full logic symbol because I kind of don't care. We did have a version of it yesterday? Okay, because that one was pretty good. Can steal 82851. Okay, 8251. All right. I really hate dealing with KiCad library stuff, but all right, we're gonna have to figure this out. Oh, you're right. You can do something like that. You're going to add a Duck Talk expert to your resume now. All right. Where's the schematic? Oh, wait. It's all here. Okay, I got it. I'm. Yeah. All right. Fine. Wait. Delete directory. Oh, I'd probably make a pull request for that, wouldn't I? All right. I'll just download the thing. Oh, that's their user. Hold on. Here. Download. Oh, we're just ripping off everyone's projects for this today. You know what? I don't trust KiCad. We're gonna go ahead and save this. Just make sure it doesn't, like, close it. Alright, schematic editor. Oh, man, that's a lot going on. Is it this thing? 8255? No. Is it this thing? 8259? No. Is it probably that one, because it's weird, right? 8251. Yep. Okay. Why didn't they fill in the body? It's not that hard to do. Alright. Cough. Huh? That was easy. See, I would literally just make the symbol and footprint for this, and it would take far less time than to do import in my experience. Yeah, no, I agree. Redeem posture for 200 points? That's impossible to do. I'm sitting on a stool. Posture is always going to be terrible here. I was debating whether or not I would try and set this up at my desk, but it's just, that, and then it's really hard to tell from the camera angle, but there's like no space at all between the stool and the table height, so it's almost like I'm sitting on the ground. So yeah, it's bad. Copy pasta also works, yeah. See, a symbol in the editor shows same background filled in chips by default. Yeah, I don't know. Yeah, I don't know what happened here, but whatever. I will take the easy way out and not deal with it. All right, they don't have a 26 LS32, do they? That'd be real handy. Right click, edit symbol. Isn't that easy? Edit footprint. Oh, edit with symbol editor. Hello. Let's go ahead and throw a background in there. Actually, I think you just... the shape. Alright, you hit E. That's right. Edit. Line width. Fill with background color. Boom. Alright, there we go. Save. That. There we are. Much better. All right, I'm going to go to here right now, though, and I'm going to look at the difference between the 2632 and the LS3, or the 7432, and I want to see how much of a pain it would be to just copy paste the 74 for the 26. Yeah, so realistically, this wouldn't be too big of a problem to change. So I just need a... yeah, just basically replace the round bits with triangles. It's not... oh, wait. That changes it, though, doesn't it? Get 26LS from here? All right. Whoa, what is this? com.lib, okay. How do I... oh, just download the whole thing. Okay. What is this hour left to download? Okay, it's picking up. You got my interest there, Taters Games. Let's see if it has that. Add, paste. It doesn't look good. 172. It's got 3 bits to it. 3 bits. The schematic shows it's got more bits. So this has 4 things and whatever that is. These ones all have 3. Old line buffers usually not in the library. Alright. Well, we'll just let that maybe finish. Is it really going to take 3 minutes? Ugh. Alright, we'll move on to the next thing. Starrock, how much PCB design have you done? Because I've used other PCB design programs, and I feel like half of the time is usually spent creating parts just because they don't have them all, and they really can't have them all. It's just how it works. So I'm not inclined to blame them for not having it. But yeah, it can be annoying. I kind of agree, Condarsa. I really like KiCad. How do you feel? Yeah, okay. Making parts in Mentor pads? I'm not familiar with Mentor pads. Perfectly normal to design the symbols as you go. Yeah. Okay, Starhawk. Yeah. So all EDA software is like this. You spend a lot of time working on schematic symbols and footprints. It's just how it works out. There's too many different parts. They can't standardize them all. Was the LS2631 included in that download I'm working on trying to get? Because that would be nice. Whew, it is. Okay, so that's a double... oh, it's done. Perfect. Okay, so we need com.lib. This one. Okay. What's DCM? I don't remember where that file is. Are these like an approved open source type thing? Like I'm good putting these in the GitHub repo, or... because I don't know. I don't have no idea what this site is. You know, I'm just going to assume since it's open source hardware, sure, why not? Only get the 2 symbols? Alright. Yeah, but since there's no project I can copy paste it from, I'm going to have to open it. I'm going to have to add the library, which is fun. Okay, yeah, I know. It's just, I always forget how to do this. Can I just, like, drop it in here? That would be really nice. Hold on, let's try that. Nope. Manage symbol libraries. Okay. Add. Of course. Wait, library path. What is this? Sim. Okay, hold on. Home. Am I doing this totally wrong, Helicroft? This is not going to work? Because it seems like I'm going the right direction. But, yeah, that. Okay. There. Okay. So maybe. Let's see. I think it'll appear at the bottom. No. Okay, do I have to update this? The browser might be updated. Okay, I don't see it there. I don't see it there. Just search now? Yeah, but I think it didn't actually import it. I think it didn't do it. 26LS32. Yeah, it didn't actually do it. I was opening. Yeah, you know, that's not a bad idea. Let's do that. Let's see. Save. Just save. Okay, close. I'm gonna have to make sure I have all instances closed here. Close. No random PCB news running around. Okay. Open. Why are there 2 things? What is Pro and KiCad Pro? I have no idea. Whatever. Symbol editor. Okay. Does it actually show up now? There it is. Hey, we got it. Okay. Schematic editor. All right. Add. Oh my gosh, this software. All right. Of course, it's not filled in. Why would you want it to be filled in? Okay. 1, 2, 3, 4. Was there no 5th? Oh, each one has power and E, right? That's what that E is? What is that? Why don't they have pin numbers? So, oh, okay, just that one has, all right, this is the bad way of doing this. All right. It is powerless symbol. So, but, so it just means that this is power here, the 4 and the 12, right? Those are the ones that are power.
The Torskens says CHER 100 YAMA 16,702B logic analyzer just got delivered. Now to put it through its self-test routine. End of line.
That's awesome, and thank you for the 100 bits. 4 and 12 are the enable lines. Oh, okay, so it really doesn't need that. It really doesn't need that. All right. Dr. Hugh, I have when I was using dip trace. It is very annoying to do all this all the time. It assumes you supply the VCC and G&D and uses those net names. I hate that so much. Wow. $16 done it for a long time. Yeah, yeah, you definitely get to a point where you just realize anytime you pick like a weird part, like I was doing some weird stuff. I had to, like, I was doing a project where I was using a digipot, digital programmable potentiometer, and that one was weird, and I definitely had to make that part. So plenty of things like that. There was one where I was using a multiplexed switch. That one was real. That part was really cool. It had like 16 inputs and then 2 outputs, and you can latch any of the 16 inputs to either of the 2 outputs. Yeah, that one was really complicated. It was a fun part to work with. Did some cool stuff with that. Okay, there's the 3 one. What's that part number? Also, let's just make sure, for sanity's sake, G&D minus 12 volts, VCC. So it'll be VCC? Yeah, VCC. Okay. I don't like that. I really, really don't like that. Anyway, this is 7120. 7120. Hey, look, that took like 30 minutes to just do one part. That feels very schematic editing-y. Is this gonna have a footprint associated with it? I have a feeling not. Library link. Footprint. No footprint associated. Okay, so we'll have to add the, like, what, dip 16? Yeah, to that later. You may want to redo after stream to your liking and make sure it's open source. Yeah. Yeah, the making sure it's open source is a thing for sure. All right, let's add the other one of dubious quality. Yeah, LS32. That'll get us there. Oh, look, a bunch more that are all weird. Okay. Oh, those are super weird. Wow, that's a funky symbol there. All right, so 7121, yeah. I'm glad these are actual shapes and not just like a bunch of lines that are all connected. Makes the background work easier. This doesn't have to be filled for any particular reason. It just, my thought, makes it easier to read, and that kind of thing matters more on stream. So, yeah. All right, there we go. For those who can help, I can post what's going on with Visual Studio 2022 project referencing issues. All right. I don't know anything about that kind of stuff, so I'm super useless there. Okay, we got all the 595s. We need to do the 04 and the 74 still. Also, the 125, did we not do that? Hold on. Above that, that's a 74. What is this? 711. 125. Wait, did I mess that up? 713. Oh, I did mess that up. Okay, well, we don't need this then. Okay, now we're gonna add HC74. There's 2 of them, so it'll be here and there. All right, let's see if we got this part. HC74. Oh, goody. Wait, why is it 3 parts? So, all right, fine. Is it a power or is it? Yeah, okay. Okay, this one is 7113. And it goes with these. A lot of manual work to have to do for all this. All right. That's 7112. Okay, now the 04. HC, is it? Yeah, that. Okay, perfect. How many parts is this? It looks like a billion. 1, 2, 3, 4, 5, 6. Holy moly. That's a lot of things. And we got the 3, 6 something over there. Here, I'm gonna move this over slightly so I can fit all these in here. That's good to know, Taters Games. I think I've so far actually been able to mark all the HTs as HTs on here. So like 138 down there is actually invisible. No, HT right there. So that's good. And all the other ones are HCs. That's part of why I was marking the full part numbers that are on the chips on the GitHub repo. So I'm going to try and order as close to those as I possibly can. I'll even be stupid if there's like vintage Philips chips on eBay that I can get. I will probably do that just because that would be cool. Oh, I did mess that up. Ugh. Where'd that come from? What? Did I copy that? Oh, that part was from the Monster FDC. Okay, yeah, we can just rename that. How about that thing? 74 HT 244. Okay. 245. Five 595s are all HC. That's LS. That's like different. Oh, you know what? Actually, hold on. These should be kind of better aligned over here. good catch. I did miss that. And I haven't put ref deses on those. Seven, 1, 1, 6. 7, 1, 1, 7. I messed up. Ah, that one is, yeah. All right. Thank you. 7, oh, 7, 1, 1, 8. There we go. Okay. That is 7119. Not that you could really mess that one up, but you know, better practice. Okay, this is 7. Good grief, 0. Oh no, I gotta update all billion of these. Ugh, gross. 7, 1, 1, 0. I haven't even started the reverse engineering process yet. This is so painfully slow. It's always this slow. These are just never these are never fun to do. All right, let's put the 4024s up there. I'm gonna guess these are not in there because that's a weird number, 4024. What? So lucky. Boom, and it's a single part, nothing weird. 7115. Skip a spot. Wait, is it on top of the 595s? No, we just haven't done that area yet. Okay. And this one is 7114. 7114. All right. So that was the 04. Now we need to do 368. 368. Fingers crossed. There's an LS. We're gonna use that. What's the difference? What is there? IEEE. Oh, that one's gross. We're gonna use this one. I don't know what the difference is, but I want to use this one. All right. I'm gonna rename that to just HC. Is it possible the LS and the HC parts could have different pinouts for the footprint? I'm probably just gonna have to double check that all, no matter what. 7109. And then it's the same. All right, cool. So I probably won't have to update the footprint on that one. Wait, is that all the chips? That's all the chips? We're ready. Oh man. Blah, blah, blah. It's only like an hour left in the stream. Good grief. Missing 125. Where is? Oh yeah. How did a giant hole in the middle of the schematic? Oh, I'm done. 125. Oh no. Why doesn't it have it filled in? LS 125. We'll go with that one, I guess. It's another 4-parter, 5-parter. Awesome. And it goes there. Okay. Let's schematic unit should be the same, just change the name. Yeah. Alrighty, so I'm now thinking that I may not have properly changed the parts over here for everything. I'm curious how that's going to work. HC, LS. I think that one actually is LS? No. Okay, so that's wrong. And I'll look over that all later. It doesn't matter for right now. Okay, and yep, those all stayed the same. Because why would we want to change them all at once? 7111. Okay. 7111. Copy. I really miss not having a numpad on this keyboard. But it's so much easier to take with the laptop. All right, now everything's in there. Blah. Okay. All right. I do need to figure out what this translates to down there. That part's really confusing to me. So I'm sure there's a bunch of people who are here who can see that and like, oh, that's this pin. But I don't know squat. So A31, would that just be this? Is that ground? I say top left is address. I don't know what you mean by that. Its symbol pin, that's okay, so you're saying that's pin 62. So I'm just gonna do the thing where lower half lines up at the front of the card. Okay, so you're saying that is SA0, SA1, and all that? I'm just gonna have to visualize it. Okay, but I think for my own sanity, I'm gonna have to visualize this. Why do they all have transparent backgrounds? There we go. Okay, so data 15. Oh wait, that's 16 pin. I'm an idiot. Hold on. ADDR0. Okay. So, okay, ADDR A31. Okay, I'm starting to get there. Starting to get there. There. Now this lines up more like what I want. So these now line up with the pins on the bottom. I just mirrored the whole thing. So that should make it a little easier to understand. I don't really like having named nets for everything like that, where you don't actually run. So like the thing here is, let's take this one right here. So this would be the 5th pin in, all right, and it would go to the first pin 1 on 7104. So that would be unlabeled, seriously. 244. That's 7102. Hold on. 7102. And I probably didn't do the other one. 7101. 7101. Okay. So it would be this. All right. 7105 here. Okay. No. Oh. No, I can just move these. All right. Meh. Eh. Anyway, I was going to say, normally I like to do this, where I run a big old wire all the way over to the thing. But there's so many that are going to go to, like, everywhere here that I assume I probably don't want to do that. So I think I will actually use the named nets this time. Because I think it makes the most sense in this situation. So I will just... What's the insert key trick? I do have an insert key. Press escape to cancel drawing. What is the insert key trick? Draw the top wire. I don't know. I don't know what it's doing. I feel like it did do something. Whoa. Oh, wait a minute. So does that just keep pasting down, like, right beneath it? Oh, that's weird. Okay, and then I can just delete them? Okay. Alright, that makes sense. Okay, 2... Yeah, these all go for the next 4. Okay. So 1, 2, 3, where's pin 4? 4 is there, E... Okay. Also works with labels. They auto increment. Ooh, that's fancy. All right, so if I do... Whoa, what happened over here? Ah, I see it works with labels. Good to know. I'm going to copy that. Bring it over here. I'm going to paste it. Rotate. Boom. Insert? No, I did it over here. Yeah, why did it do it there? Move. Rotate. Insert. Nope, this is going over here. Create new label. That would be sensible. But that's all I've got for right now. I need to figure out where these go. So let's work on that. You know what? Actually, I want to spend a little bit of time on trying to make this easier here. So I'm gonna see what I can do. I'm gonna duplicate these layers. Duplicate. Duplicate. Group. Insert redos, the last creation. Yeah, okay, that makes sense. Okay, that's good. So I'm going to leave those there, and then I'm going to come up here. And I'm going to hue shift this. So I'm going to do a bunch of stuff. Levels. Feel like labeling the entire board might be difficult this early if the same bus exists behind buffers. Well, these are the most important ISA bus lines, so they get precedence. There we go. Ooh, you know what? Hold on. Overlay. There's got to be a method here that'll work. Add. Where's add? Lighten only? Haha! There we are. Okay, now we kind of have all the traces overlaid. So we can see this a little easier. So those don't continue. They go off to that chip. And then that one goes... Oh, this is fancy. I like this. This is cool. Why does that have a pad there, though? That doesn't make sense. Let's look at the actual... let me group these and make a photo for that. X-ray. KiCad trick, the insert trick, when I told it to tube time. Alright, I'm curious. Oh, I can't hear anything. Actually, I just may not be able to hear anything.
Nothing happened. Draw one line and then hit insert. Okay, let me try that. Nothing happened. Haha, that's a fantastic feature. After that, label the first line and hit insert to label the rest. Wow, thank you. Alright, so let's go and hit that. Call that A1, enter, click, and then insert. Dang, that just saved me a lot of time. That is an awesome, awesome trick. Thank you so much.
Yeah, that definitely works better when you do it the correct way.
I've been doing it for years the other way. Oh,
That is cool, though.
one line.
All right, let's get back to this. So, yeah, it's really just a pad that sticks out for no reason. I wonder if that was a test point for them. I'm gonna guess it was. Anyway, let's go back to the X-ray view here. All right. You know what? I feel like maybe starting by connecting everything from the ISA port is not a bad idea, and then we'll work our way up. Yeah, test points. Yeah, that's what it seems like. And for those who may not know and see what's going on here, these ones that are rounded but don't have matching pads on the top are just, they're not vias. They're only pads. They're just circles on there that don't have the hole drilled. So that's what those are. See, maybe the pads are test points. Yeah, that's what I'm guessing. Test point for production. Go from outside in. I've never done this before, but I can see that being beneficial, so I can try doing that. I was just going to try and make sure that I do every single pin. That's why I was going to go like one chip after another, snaking up. Ooh, that add only doesn't really work too well around the edges, but works really well in the center. So after the ISA slot, do DB15. Oh, okay, I see what you mean. That makes sense. It's time for you to go. All right, see you later, Jout. All right, well, let's start here. So this will be address 0. Goes over. Oh, this is going to take forever. This is going to take so long. Oh, wow. All right, here we are. Address. Actually, hold on. I messed this up. Because this is address, like what, 1, 2, 3, 5? Yeah, so this should be address 4 over here, not the other ones. So, all right, I'll do this correctly. Delete, 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 delete. All right, label. Ah, what? Here we go. Click A4. Boom. It still didn't work. Why do you taunt me? It's putting them all over there. What? Why? I created it right here. Is it could be finding the other one and then doing it there? Okay, L, A, 4. KiCad bug, yeah, maybe. Okay, it's there. Insert. Oh, this time it worked. Weird. All right. Well, we'll go with that. Okay. So just to reconfirm here, this goes to A 0, 1, 2, 3, 4 goes up to pin 1. Okay. Checked. And it goes all the way down to 0, 1, 2, 3, 4, 5, 6. You know what would make sense? How about I just label the pins on here? I feel like that's not a dumb idea. New layer. Let's make it not white. New layer. Transparency. Reverse engineering is a pain. You have to get into the designer's head. Yeah. Creating new is... It's not too bad. Yeah, I've never done this before. It's, I can tell, is already going to be very frustrating. All right, I'm going to match the terms here. It's a shame there's no way to rotate the text box normally, because I want that. Oh, I'll just make the font small. And not white. That would be smart too. S. Whoa, that's way too small. 50. And this. Okay. SA 0. Okay, let's make this a little smaller. Let's leave it tabbed though. No, resize it. Oh my gosh, I hate how text works so much. I'll get this done and then I'll go to update it and then it won't work right. This little bug is driving me insane. SA 0. Okay, that's probably a reasonable size. SA 1. Yeah, it'll work. Okay. Timing and state modules, the logic analyzer is throwing VRAM errors. Oh, that sucks. All right, I'm gonna rotate the whole picture, add text, rotate back. I would have to rotate the image. Image, transform. I guess I could do that. All right, let's try that. I didn't know you could rotate the whole canvas. Ah, gotcha, you stupid bug. All right. Yeah, let's try rotating the whole canvas. Delete. That's right. You also don't need to make a layer for text. It always makes a layer. Image, transform. Rotate clockwise. All right, let's try this. I'm curious if it'll rasterize this after this then. This will also make alignment way easier. 40. And why is it not? Oh, because I'm in text mode. There. Seconds is okay? All right, that's good. Thing is sold as guaranteed fully functional. Ooh. Good luck. Okay, SA 0. Oh, negative. That. 0. Okay. SA 1. SA2, another ISA card that only partially decodes its IO addresses. So, what is that going to mean for me? Okay, that'll work. Also, align to right. SA7, SA8, SA9. Okay, so we got invisible ones that will work, but it uses a lot of the higher IO addressing due to aliasing. Ah. I'm guessing that these here, the 300, 310, 330, 340, are the addresses. So this is in the same range then that the network card that I was using is in. So this is going to have to be mapped around the network card, I'm guessing. Okay, so this goes all the way to SA19. Oh, who would have guessed that the next pin is not part of the addressing? Okay, it's AEN, whatever that is. Oh, it's just AEN, AEN, okay. And then IOCH something or another. Doesn't really matter, it's not used. IO underscore CH RDY. Then data 0 through 7, I'm guessing. D SD. Wait, where is it? SD. Instead of 300 also show up at 700. Oh, that's gross. That's, I did not know that was a thing. That's awful. Why do I have one extra? Oh, there's a clock. Or IO check, I guess. I don't know, whatever that is. CA or IO underscore CH CK. Okay. Boom, we got them all. Okay. Address enable signals that the value of ADR or something is ready. Okay. It is valid. Okay. All right, there's all that for top side, and then bottom side's got like 5 pins, so it's really not going to be that difficult. Just go ahead and do that. Top pins. I am going to duplicate that though, so I don't have to change the settings. Bottom pins. Oh, I'm gonna have to type them all in so that I know where I'm at. Great. Wait, did they omit a ground for no good reason? That's a ground at the end? That's weird. Also, why is my mouse cursor stuck? Oh, that was weird. GND. Alright, let's just do this. OSC. VCC. Okay, this does not make sense that these are not connected. Those have got to be down at the bottom, right? Is this wrong? Am I doing this wrong? LE, because this does not make sense to me. IBM limited the... Oh, wait, I can check the image. No, those are... That's right. What? Why did they just not connect to those? They just... These redundant power pins, you don't have to use the extra power. I don't like that. I would have preferred those be connected. I am probably going to connect those. Well, I'm going to have all the gold fingers there because I'm not going to cheap out and just like lose 2 pennies worth of gold on there. So we're going to do that. So we will actually connect all of those. It's not a ground? What? Not ground? What do you mean? That's not ground? You sure? Because I have the IO whatever check thing over here marked. If that's what you're talking about, Starhawk. But if you do it's not 100% recreation, that is true. I kind of do want it to be that. Dang. Yeah, I might let the 100% recreation override that. I'm guessing this thing does not use an IRQ since it does not have an IRQ. You have side A and B, side C, side A and side B swapped? What do you mean? This is the bottom side that I'm annotating here. That end, the far end away from the card edge, is ground on that side. So this is side B. Side A is labeled, yeah, but this is side B here that I'm labeling right now. I have no idea what DRQ is. It uses whatever DRQ3 is. DMA request? Ah, okay. I like how there is an unused pin. All right, there we go, all labeled. So it uses. Yeah, that's it. That's its only ground pin. Is that one? Wow. Maybe eventually make one repro and one tweaked version. Honestly, once I get it working, I'll probably just forget that I even made the card. I just don't like that. That's it. That's the one ground. That really bothers me. Wow. All right, there we go. We got top and bottom pins labeled on the thing. Now let's see what happens when we rotate the image, because I have no idea. Transform, rotate counterclockwise. Yeah, it rastered him. I had a feeling. Oh well. Doesn't really matter. All right, bring that back. Okay. Oh. Now remove the nets that are not on the card. Oh, yeah, that's good. That's a good idea. So 10 through 19. I want to remove the wires too. Boom. AN is. All right. The IO some or another is not. Looks like that last one's disconnect. All digitals are connected. On the back side, we got barely anything. Yeah, those aren't. So we can go all the way to SA15. Oh, wait, hold on. No, not that. Boom, boom. Okay. DRQ3. Go all the way to that. Gone. IOW, and that's it. To the 3 powers up front. Get rid of the wires. Boom. All right. The 12 volt was not used. Delete. And this is ground. Do I have a ground bus? Oh, I think it was over there. Okay. So we're going to add G&D. Boom. Okay, there we go. G&D is in the chips you stole? What? I don't know what you mean. Good spine crunch? I don't even, was it? I guess it was. I wasn't even thinking. My back hurts because stool sucks. This was not the best way to sit for this long duration of time. I really should have set up a desk. This is not fun. It's not a problem when I'm up and down and moving all around, but standing to computer is not my bag. I may do it a little bit here though, because yeah, that hurts. Bottom left chips have ground part. Oh, okay, there we go. Yep, you're right. Okay, and same for VCC, which is 5 volts, I assume. All right. Okay, now we got that done. I'm half tempted to just do the backside since there's so little, but we'll continue from the left here. Okay. So A0 goes to pin 2 on 7102. So 7102 here, pin 2 is that. So go bingo, boom, label A0, bingo. And then, wait, what? Oh, A0. Wait, did we properly label this? Yeah, I think so. Okay. Yeah, all right. A1 goes to... Ooh, that's complicated. We're not sure. We can't be sure. That's a question mark 1. We don't know. I'm guessing that this one, where does A2? Yeah, that's, where does A1? A2 goes to here. It's pin 2 of 105. So A2, 105. Wait, what? I messed these up. These all go over here. Boom, there. Okay. A2, bingo, right? Goes to pin 2, A105. Okay. Label. I do know what you're getting at. A2. Swap the 2 chips instead of renaming. Well, no, that was my fault that I didn't do it. I messed it up. That was what it is. Okay, so from context, can we determine... Stop it. Let's look at this. What? Okay, that goes up there. From wherever that is. That's not a via. So that one just goes to nothing? That one also goes down to nothing on the back. So those are test points. But that's... Okay, so that would have to be internal. Then it goes under. That's what it is. Yeah, top side. Yeah, I was getting there. It's just taking a while. So top side. So we have these two here, but the other thing is, if we go back to the X-ray view, why did I hide all of these? Oh, there we go. Boom. If we go back to the X-ray view, we have these two vias here. One goes down and one goes up. And it would make sense for this line to... I'm going to add a label thing. Drafting. Alright. It would make sense... for this wire or trace to continue there, and then this one, nope, that can't work. That's ground or a bus. That's whatever that big thing is. So this definitely continues there. That goes on to wherever. We don't know where that one ends. So that probably goes there. So this may go here. We don't know. These are speculative. G&D's bottom right pin. So that one, pin 8. Yeah. We don't know what those buses are. That might also connect to VCC. It does connect to VCC. So we know that's VCC. Because if we look at the bottom labels, that's VCC. So top rail, VCC, probably the same on all of them. Bottom rail is ground, because that's a ground bus bar. Any chance? It's not a multi-layer board. It's definitely 2-layer. So pin 16. What? So that would be what? This one? So that is pin 876. So E2, could they just be tying the address pin high with that? Because that's weird. Well, think about this for the test point traces. All right, if we go back to the just the photographic view, we can definitely see a trace on the top side comes into pin 2 here. 100% that's connected with that trace. And then if we look at the bottom side, we can see this comes out for no reason. The only reason that would exist at that point is a test point or a vestigial leftover from a previous design. Those are the only two reasons for that to exist. Test point or old design leftover. So, yeah. Pin 6 should just be high if not needed. That's what I'm thinking, Helen Croft, is that would make sense. So leave that high for addressing, but then that means that that's just tapped off of there. So we don't really know how many of those kinds of things there's going to be. Because there could be other, well, we would see vias, so that's a thing. Test point for sure, yeah. So that's test point, that's test. That could be tied low. So that's a potential unknown. We don't know. And then we can see, it looks like there's a trace on the bottom side for address 3. Where's that? That snakes off. Oh my gosh, that goes everywhere. Okay, so we actually have one here. So address, yeah, A3 sneaks around under that chip, comes over to pin 3. So A3 is, man, they had to go a very circuitous route to get there, but they did get to A3 correctly. So wire, boom, boom, A, no, not A, L, A3. Okay, so that's right. So A0, we don't know, could be tied low. It doesn't look like it goes anywhere, but we have, ooh, that's weird. It's possible this trace is different on each side because there's two vias here side by side. Or maybe they're all connected. Maybe that is, no, that doesn't make sense. Because that's an address. Some other I have questions about, but that might just be me. That point be a detector or relative lunar humidity, yeah. Left and right are different. Yeah, that does make sense. Well, all right, so we got A0 confirmed, boom. A1, we don't know, goes up to there, but then we can't see where it goes to. It's possible it goes to pin 1. So we can say, we can mark this as A1 with not sure. So that's speculative. That's something that I should probably have them check. But that would make sense. I don't see any reason. There's no other vias that go in the way. So that's clearly VCC. That one probably ends whatever that trace is. It does make sense. Yeah, it does make sense. So, but I would have them check it for me. That's one to definitely, it's a multimeter away from knowing for sure. So. All right, as we are getting closer to the end of stream, I'm not saying I'm ending it right now. Do you guys prefer I do more of this part on my own, the raw random tracing out stuff, or would you like to see me continue working on this some more, like tomorrow? Because I'm going to be working on this still. There's a lot left, clearly. And I'm just wondering, is this stream preferred material, or would you like to see something else? We want to see it all, because we can do that. It's going to take a long time, I suspect. So, all right, this is every single dirty shell. All right, I need to bring back the top side pins. All right, there we are. So A8 all is good. All right. Do the data lines now in like 10 seconds. Yeah. So those are probably going to be easy. Let me finish these two data line or address lines because these are pretty obvious. We know where these are going. So A8 is going to 702 or 7102 to pin. That's -4. So it's at 20 pins. It's 5. So 20, 19. So 20, 19, 18, 17. So A2 is pin 17. Or not A2, A8. And then this is 1, 2, 3, 4 is A9. All right. Now we can do the data lines. Oh, AN. Is that one super easy? Yes, it is. It goes back to 102. AN goes to pin 11. So pin 11. Boom. Never too old to learn. Yeah, this is new for me. I don't yet consider myself old. I'm close to the point though where I will be. AEN. Okay, double check. 11. Yep, good. All right. All right, data lines. Oh man, these are so hard to figure out. All right, so this is 101 here. All right. 2, 3. I am the Ray Mondohim. Hello, since first time chatting. So I'm getting flashbacks and reverse engineering my Compact Portable 3 memory expansion. I'm listening. Guess what's in this bag? I don't know if I have a memory expansion in there. I did get it running. I'll let you know how it turns out. All right. No pressure, just intriguing. All right, so this, I can literally rotate this, move it to there, and then all of them will line up. That's it. Oh, no, actually over one more. Boom. Yeah. So if we just do that, then done. See, will that? Nope. Do the insert trick. I think I can do this a couple of different ways here. Hold on. Rotate, because I can do the insert trick. All right, so 1, 2, like that, but then it will actually kind of be quicker to just do this. Boom. Because now I can just go through, boom. And there we go. Now we've got them all. Same outcome, different method. Actually, I kind of want to do this. Bring them in a little bit. There we go. All right. So there's that. Okay. So SD7. Oh, it does go to that. Okay. And then that one. Actually, I'm confused. I want to see the full detail there. They have that pin, but then it doesn't go to anything? Or does it go to... Yeah, so that's their only non-connected Goldfinger? Is that it? Because there's a pad on the other side. It's not a via. It's not going through there. They all have test points. What do you mean they all have test points? I'm saying, well, they didn't put all the contacts in, so I'm saying that one is not connected. It doesn't have a test point on the other side. The data lines. On the other side of the board? Some of them do. Oh, most of them. Maybe not. There it is. Yep. Okay. They all have test points. Oh, yeah. You're saying I'm going to need to be adding test points. Yeah, I hadn't even considered that. I will have to add test points. You're right. I'm going to have to recreate that weird teardrop shape as well. Now that I think about it, it's like a little tiny bit of a trace sticking out. Yeah, it's no connect. Well, it's just weird because they omitted all the other pins and then they have that one that is no connect. That's all. So. So yeah, I think if I look over this whole thing, yeah, I can shift this top layer just over a tiny little bit here. Let's try this. Boom. Yeah, that was good. Okay. Forgot to remove the pin. What pin? I have those. That's address line. The pin is there. It has a no connect on it. There's that. I don't know what pin you mean I forgot to remove, though. Oh, you were saying they forgot it. Oh, okay. Yeah, sorry. Bleh. All right. All right, let's try the backside here. So VCC, well, actually, this is going to be really easy, isn't it? VCC is there. We just have whatever that one is. Reset. That's a big, complicated label. All right, let's figure out where this goes. Oh, you know what? I also wanted to do... I kind of wanted to mark these, and I forgot to. I'll do that in a moment. What was I doing? This, reset. Reset to boom, boom. Oh, it goes on a big old long journey. Okay, so we're following... You know, I'm gonna do this. Boom. Boom. Boom, boom. Boom, boom, boom. Great. Is that pin 1? It might be. I think we can fairly confidently say that's pin 1, but it disappears, so it's not totally sure. That would also mean reset is optional. Ooh, that's cool. Since there's no socket, we can actually see that trace. Or nothing in the socket. Also, that's really scary that there could be some that just disappear, that appear and disappear under the chips. I don't know where that one goes for sure. I could go to either one of those. That chip don't need reset. Well, that doesn't reset something else though, instead. That should be VCC. This one? That's not VCC. That's reset right there. Oh, you're saying on the chip that should be VCC. Yeah, that would make sense. That is 21. That? No. Where is it? Up there. Okay, 21. Oh, that's right. It's a stupid thing. Okay, I don't have that marked there. Wait, pin 1. Hold on. Is it? Are you sure? Because pin 1 on the footprint that I absconded with from that website is that. It's an input. You're right. That is the last pin. I'm an idiot. How many pins is it? 16 is 16 labeled? Of course not. So that is power pin, most likely. Okay. All right. So that'd be weird if they tied it to ground there. So yeah, I don't know where that one goes. I don't know where reset goes. So that disappears there. Possibly it goes to here. So let's say we're guessing it goes up to here. Let's just say it skirts along the outside of those pins. Maybe those pins aren't used. Maybe they only needed like one part of that chip. Let's just pretend. You're saying that's VCC as well. So this is the VCC rail, let's say right here. So this would connect like that most likely if that was power. So we'll say, what did I do? So we'll just pretend this continues along like that and we just can't see it in the shadow. Like I could see that, all right? It goes up here. Boom, 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 boom. Whoa, I did a thing. To there. Bottom side. Yeah, so it goes to whatever pin that is on that thing. So 28, 27, 26, 25, 24, 23, 22, 21. Pin 21 on here. It is the reset pin on the UART. Aha! Okay. I feel fairly confident that that's it. I'm gonna grab that weird label because it's labeled weird. Copy. Boom. I feel like that's a very high likelihood, but I'm gonna mark it as not sure just because we don't actually know. And if I'm having them check any, I might as well have them check that one as well, just to be sure. %, sure. Yeah, very, very sure, just not sure. Not 100%. But yeah, it makes total sense for that to be it. Okay, so now that's all pins identified. Ooh, I wonder where that goes to. Oh, it just goes to VCC. Okay. So they want a big stabilization for the UART chip, I guess. That's what that is. Interesting. All right. Can take a look at the connector now. We are going to have to make some guesstimates. We're going to have to do a lot of guessing on that, actually. That kind of sucks. I agree, Helen Croft. I 100% agree. It is almost certainly reset. It's one of those things. Hello, Cannon Wall, since it's first time chatting. This is basically reverse engineering, yeah. We're trying to figure out what this card, well, what the schematic for this card is. That's what I'm working on over here in KiCad. And this card is the control card for this CD drive, which is the first ever CD drive. I have the drive, I don't have the card. So I gotta make one to make the drive work. So, what is that trace going to? I can see, I'm gonna do some really bad guessing here. So I'm gonna make this yellow, like warning, don't rely on this. All right, so let's say we go boom, boom, boom. Okay, let's pretend that. And then this goes to that. That goes in the middle, which would make more sense for it to just go straight to that, though. But then where does that one go? That, We definitely know where that one goes. That one's obvious. It goes up like that. That one, also obvious. Only two on the back at all. Right? Those are the only ones? No, there's one there. Okay, so we know where that one goes to. That one's also easy. It has a via. I don't like that. For some reason, there's a via. Extreme has lots of novel things. Is it a face-chasing camera? Yeah, this does follow me as I go around. It's software, and I will do this in chat so you can see how I'm actually doing that. I've definitely determined that this whole tracking thing is nice to have. So I'm liking that I can do it. So, okay, this pin probably goes to that. That one probably goes to that. This probably goes to that one. That probably goes to that one. Which would then make sense if this one went like that. Top trace is shifted down compared to the pins on the connector. Maybe, yeah. It's nice to have until software loses tracking and gets creative. I mean, that happens, yeah. I don't think it's the worst thing when that happens. Well, okay, Helmcroft. As far as being shifted down, so I can realign this slightly better for here. So let's say it's like that, all right? I've aligned those vias. So that one, I feel like the stuff still kind of makes sense. Yeah, that one goes in through there. That one goes to that pin. That one goes to that one. The only thing that doesn't really make sense is this one trace right here. Parallax error in the scan. Yeah, well, just because they're overlaid. It should just stop in place when it loses tracking, but it keeps and zooms into random things. Yeah, so Jack of Clubs, the reason it does that is because it's emulating a physical camera motor control, and those work by moving the camera starting a rotation until the face is in the position where it wants. And once it loses the face, like down here, it keeps moving because it keeps trying to put the face in the position it wants, but it never can because the face is gone. So that's how that ends up working out. Anyway, we have two questionable traces, so we don't know where to go. So we have, whoops. So let's get rid of, actually, why am I using that? I could just bulk delete. So we go to the top side photo, all right? It's this one. We don't know where that one goes. And then we can't see, like, the pins. So this one seems like it goes into the rear one. But then this one also goes somewhere. But this pin definitely, almost certainly has that one. Just desolder everything. Oh, yeah, let me just go do that. Let me fly over to the Netherlands. Sleeping time for you? All right, see you later, Dutch Black Cat. I'm not going to be here for too much longer. So, all right. That almost certainly goes to that. Why is this not drawing? Oh, because I have an area selected. Okay. Boom. Boom. That is a little skinny trace. That's where that pinout that someone posted, I'm a cat posted, will actually be helpful. I can't scroll that far back up in the chat history. Okay, well, let me... Top one could go around. Everything can connect to a random pin. Ooh, yeah, that's really likely. Oh, that sucks. Okay, so we may have to use context. We may have to figure out what that goes to here and then try and figure it out. There are at least 4 no connect. Yeah, I'm gonna bring that pin out back up. Do I still have that open? I don't. All right. It was something Twitter, I think. Yeah, here we go. All right, I'm gonna save this into that folder. Get this image reference, LMSI pinout. All right, pin 1 ground, and it's, no wait, pin 8 is ground. What? Pin 8, that would be, hold on, is this male side? External, the shadows make this very clearly male, so pin 8 would be this. We can put the DB15 in the schematic. We did not. I will have to do that. Actually, that might be super easy. Hold on. 15. Connector, DB15, female. Boom, done. Win. All right, there we are. Card is female. Yeah, card is female, but the printout here, that looks male, right? So down here, yeah, that would be pin 8. So pin 8 is ground. Okay, so we can fairly confidently say that's ground. That makes total sense. So it'll go boom, boom. Okay. And then those are basically no connect. You have the, I guess that part I can verify, huh? I can also just look at the card. Wait a minute. I have this. I can possibly verify some of these by looking at the actual card. Well, the wrong card, but that, yeah. All right, but let me just test ground really quick. Okay. Beep, beep. Okay. Here, that to... that might be VCC. I don't know. Okay. So far, it's actually not looking like ground. But, all right. Let's try... fix stuff by looking at the wrong thing. Yeah. RS422 driver's pinout has 5 diff pairs. Yeah, no, that does make sense. I see what you mean. Okay, here. So pin 8 would be that. Boom. Okay, pin 8 on there does connect to the shell, so that's probably ground. Good. Wait. Oh, it also connects to power ground. I don't like that, but all right. All right. Why isn't this connect to ground? Let's see. ISA ground was which one? Last pin. So, boom. Okay, ground. Confirmed ground. Okay, so that one is 100% that. And then 15, which is what? Right above it. So that's That was really messy. No. Okay. And then 14 right next to that. No. And then 6 and 7. So those are the two above 8. Wait, that should be no connect. What? Hold on. So if we work from the 26LS chips, are those differential? The 20, that thing, is that differential? You're saying? So that should have like a plus and a minus that would probably go to this? Because that will help a lot. Also, for the record, this card has an LS, a 26 LS31 and LS6 LS, the 32. It's got the same things on this. So I can beep this out to determine the pinout, probably. So I think this card just became helpful because it's got the same chips in the same connector. Chips are differential in and out. All right. So I think we may not need to get any answers on this. I think I might have everything I need right here. As long as everything goes to those, which it also goes through all the resistors on here too. Those are all marked. It's a shame there's no, oh, there is a crystal. Well, you know, it's a shame it's not the same clock speed. Oh, it actually might be the same clock speed. Yeah, I might have everything I need right here to figure out the passives. Look at this real quick, like, why is that gone? Here we go. That's the wrong one. This, boom. That crystal is illegible. Wait. So close. There we go, 4952. That's really close to the other one. The not connect should be connected to VSS. All right. But the other one is 49. What is that? 49. Yeah. Is that S2? Actually, I'm not sure now. The other one is 49152. But anyway, I might be able to measure those two to get the ones on the back. Not connected, could be connected to VSS. Yeah. Let's see. But that, okay, so that and that should also be not connected. So that one seems to be definitely not connected, but this, so it goes boom to boom to a test point. Oh, could it, wait, no, it's definitely connected to that resistor. So one of the not connecteds is going to that resistor. Now that also helps. I do know where that comes from too, but yeah, pin numbering could be different. Ooh, why? Yeah, it is different. What gives? Wait a minute. Yeah, so what I'm wondering now, that maybe it's not a protocol difference. Pin number for IDC DB15, different interleave. Okay, so it's it's not. Might be IDC. Okay. Okay, so that's the dependent ordering for one specific manufacturer. I'm just trying to make sure I don't just need to make an adapter cable to connect that card to this drive. Because that'd be way easier than laying out a whole card here. Just making sure they didn't change the pin out. Yeah. Yeah, G-Pin, that's, probably not. It's most likely not. Yeah, sits between 1 and 2, yeah. Looks like KiCad does not have a, IDC. I assume that's manufacturer, right? IDC. So you remember them, you get the other. Renumber them, you get the other list. Yeah, okay. Alright, no easy way out. But, alright, we should probably wrap this up. Been going for a long time. It sounds like everyone. This is a dip socket crimp, yeah. It sounds like everyone would like me to continue this tomorrow. Hellencroft, I will do your gateway computer redemption at some point here. I'm not sure. This kind of snuck up on me. I wasn't planning on doing this and just until yesterday. So, yeah, because this, I was sent these images last night. That was when I got them. After trying to get the disk drive working, I guess I can switch to this camera here. After trying to get the disk drive working the other day, so yeah. I had a win with what I was doing. Can now host a MapleStory 2 server. Sweet! So yeah, I was kind of not really planning on doing this, but the person who can finish the card first, PC can wait. Alright. I don't know how long it's going to take. I don't know if we'll finish tomorrow, because, again, I'm really slow and new with this, and there's kind of a lot of traces on there. I mean, it's not like a ton, but it's more than some things. So, we'll see how it goes. This is obviously a more complicated part here with the DB15, but we can reference this, I think, to most of these. So, like, for grins and giggles, let me pick one trace on here that we're very confident about and see if it matches the pin on this. I'm guessing the SND and the through hole pads are probably the same pin out, just smaller. Chris Gort, thank you for the Prime sub. Now it renewed. All right. So let's go back to X-ray view. So it would be that. Outer pin goes to that one. Okay, that. Outer goes to top. Oh, it's going through a resistor. Great. That makes it more complicated. Wait, that one doesn't go through a resistor. What? You can refund your own points, yeah. Da, 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 da. Okay, that one goes there, and then underside. Wait, is it that? Hold on. Okay. Hey, look at this. So the 3.2. I want to look at the SMD versus through-hole pinouts. Is there a difference? That would be 1B. Hold on. Is that going to be the same as the dip? Ground? I guess that would be something else. That would be 3B. SMD is the same. All right. Oh, yeah. Here we go. SYC P dip. Okay. These are slightly different. That would be 1B versus the other one would be 3B. Okay, so they could just be laid out slightly different, but using the same inputs, outputs. Well, that doesn't really help then. I thought they might be completely identical. Get rid of that. That. Oh, wait, that's the confusing. Oh, that doesn't. Hold on. Oh, no, that's the one. It's one of the ones we don't really know. Wait, how's that just gone? There's a via, and then it goes to nothing? What? Oh, it's just misaligned a little bit. Hold on. Through splits for some reason. Goes down to here. Goes through resistor. Resistor goes to ground. Is that what I'm seeing? What? That side of the resistor goes to a via, which will connect it to ground. Looks like that resistor does too. Wait, what's going on there? Why does that look like there's a trace that just runs through those? Being pull up, pull down termination makes total sense. This doesn't. Maybe a scratch? Let me go back to the pictures. Here's what I'm gonna do it locally. This will be the last thing, and then we're done. From that ink, maybe it is just a scratch. Yeah, okay, I think that's a scratch. That would make sense. That's a little terrifying, and scratches look very similar to traces. But all right, I can see that. Alrighty. Well, okay. Poster rest pages related to the CM-100. Yeah, I think that's from the big Philips like manual of a bunch of stuff, and there's really not that much in there. That one screenshot you posted, I think, has everything about it, right? So, RS-422 needs termination. Yeah, that is another thing. We're gonna luck out a little bit. That's RS-422. We can look up like pinouts of things like that. So, yeah, we'll see how that goes. So, all right, I guess we're going to continue this tomorrow, and make some more progress on reverse engineering the card. I'm gonna go ahead and save everything I have open and then commit that to the GitHub repo. Just make sure that it's all there. All right. CD, boom. Git commit. Beginning. Schematic. It's going to take it a little bit here to do the GIMP file. Sounds like it was productive stream. Wasn't here for all of it. Yeah, I think I made some good progress. We have all of the parts into the schematic now, so we're going to be able to kind of more quickly move tomorrow. That took about as long as I would have guessed. The parts adding to the schematic, that always sucks. Yeah, but we've got that. We're starting to figure out some of the more complicated things like the pinout of the connector. Thankfully, I do have this reference so we can get some ideas, but I'm not sure how much use that's actually going to be. But we'll figure that out as we go along. We do have a couple of things now that we know are slightly confusing. We may have an idea of what they are. The address to line and the reset line. We're pretty confident on the reset line. So, you lucky I have other stuff to do. I'll do the reverse engineering myself tomorrow. Yeah, I do kind of want to do it myself, but I very much do not mind help on it because I mean, that thing is super rare. So getting another one, if I screw this up, kind of not possible. Since everything seems to be diff pairs, I think the interface is pretty much safe. It's going to be very tolerant. There's no power over it, so there's no way to accidentally screw it up and toast something. So, yeah, I think the worst thing I could do is just cross, like, data and command stuff. So, yeah, your precision is commendable. I've gone for a very long time now. I like, this is, I don't know, this is just what I do. So, yeah, that's about it. Yeah, so we won't mind if you do stuff off stream, so we have time for PCB design. Yeah, some of this stuff's going to be kind of annoying. I'm not going to be taking the card and things home. I can knock out some of the more easy to view traces, so I can do that. So, what did you end up missing? So what we've worked on, David, is we have, hold on, failed some refs. Exceeds GitHub's file size. Oh, that kind of sucks. Oh, I can't upload this. Ooh, that's not good. Ashlyn or something. Hello, it's your first time chatting. Unfortunately, we're about to end this. David, so we've been working on this. So we have kind of x-ray view of the card, and I'm working on figuring out where some of the traces go. All of the ISA pins are mapped. So yeah, you have to use GitHub LFS. I don't know what that is. So I will have to figure that out, I guess. Not right now. I can push this from home. So, but yeah, we've been working on that, and then we have all of the parts in the schematic, and now the ISA plane connected large file storage. Yeah, DMA and IO lines are not done. Wait, what? DMA IO lines are not done. What are you talking about? These ones? I did those. I did do those. I'll bring it back up. EDA, ISA card, Pro, schematic, this. So these here, IRQ, oh, you know what? Maybe I didn't do those. Oh, you know what? Yeah, I'm dumb. I did not. All right, so we got more ISA pins we still got to figure out. I was a little ahead of myself on starting on the DB15 connector. So, yeah. All right. I don't really want to move to GitLab, Dratino. I'm happy with GitHub. It's annoying Microsoft bought them, but so far they have not soiled it too much other than the GitHub Copilot nonsense they're doing. But, yeah. So, all right, we're going to end this. Thank you all for being here. A lot of fun doing deck talk stuff earlier in the stream and then throughout as people were chiming in with things. That was great. I am so looking forward to having that running long term. That was kind of awesome. I might have to figure out a different sound setup for it. The wireless audio transmission is kind of a sketchy workaround I'm not thrilled about. I don't really want to have to use that all the time. So we'll figure that out. But yeah, I'd say this overall went well. Really happy with the progress on the schematic and the card and everything. Just, it's going to be slow because I've never done it before, so I'm kind of figuring some stuff out, and kind of EDA is not really fast to begin with because you have to be sure, and yeah, just a bunch of stuff like that. But yeah, good stream. I will see you all tomorrow when we will be picking up on this. So yeah, let's go ahead and run the outro. Well, thank you all for being here and for the support. This was a fun one. And yeah, I am really happy with the progress we've made today. So that is it for now. If you enjoyed this stream, you might want to subscribe on YouTube, where sometimes I actually remember to upload the VODs, or you can follow here on Twitch, where I'm recording this, and catch them live. If you want to help support the channel, you can buy a shirt that's not one of this, because this shirt you can't get, as far as I'm aware. It's not my shirt anyway, obviously, but I have them. Or you can find me on Patreon or sub on Twitch. But for now, that's it, and I will see you next time.